Okay, how's everybody doing? Get this screen here just properly set up. And yeah, cool. Let's get this show on the road. Hey folks, how's everybody doing? Palm 57, Intel FX 86, welcome, welcome. Need a CL650 screenshot. Soon. Hey CL650 pilot, welcome, welcome. James EGCC, hello there. VMAUX. And you folks all, well, you probably can't see me all that well because there's a giant bunch of light there. Just stand by, I'm gonna fix my camera here just for 1 second. And let me see. Oh yeah, sure. The other light. Let's see if this helped. Maybe you can see me a little bit better now. Yes, perfect. Actually, you know what? Stand by. I'm just gonna take 2 minutes and I'm gonna fix that camera. Now then, let's see. This helped. Maybe it did, maybe it didn't. Oh, yes, it did. I think it did. Reasonably well, anyway. Hey, Captain Zap. Good stuff. Yeah, indeed. Hey, hey, sup. Oozleman. Welcome aboard. So, what data displays do I not need? I don't need you. I'm gonna leave the frame rate there just because I can. Cool. Let me actually, just for 1 sec here, like that. And I gotta go fix that. And let's go. Cool. So you saw there a little message, a little blurb, which occurs. I guess we could talk about that. I'm going to disconnect from Pilot Edge and I'm going to invoke it again here. So if I reconnect up to Pilot Edge, go ahead and reconnect. Call sign already in use. I got to give it a little moment to time out that old call sign. And so when I reconnect, you'll see the message again there. Let's see now, will you let me on? Not yet. Probably heard this about 100 times a day, but new to the stream. Development is looking incredible, really forward. Cool. Can't wait until it's out. James EGCC, thanks for the kind words. Absolutely, we're looking to get this out ASAP. Now it looks rough from the look of the cockpit here, but I'm running fairly old mesh. There's already new mesh on the way. That's gonna look a million times better. And the airplane systems are almost all there, and avionics are almost all there. So at this point, it's mostly about adding not directly airplane features. For the last, there we go. The last major piece of avionics I just got done implementing yesterday would be the standby instrument here. And then there's just little bits and pieces here and there. And we gotta follow. Fragilitis, thanks for the follow. Welcome aboard. Cool. Anyway, so what do we do here? What is this message all about? So in the aircraft, what we do is we simulate and tune in just to see the new ISI. Been staring at that black hole for a couple of years now. Yeah. Well, actually, so for that, I'm actually gonna go ahead and actually, am I gonna get external power? Yeah, sure, I'm gonna get external power. What? Hang on. Something's wrong here. Oh no, what happened to my click spots? Goran, you move the click spots around. Oh man. let me just quickly fix that. Or actually, can I? Let's see. Oh, he's already pushed that, hasn't he? Blah, 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 blah. Hey, John Fly. Welcome, welcome. Anyway, so I guess I'll just kind of have to guess where everything is on the overhead there. So yeah, here's the ISI. Hey, Match B77, welcome. Where the clicks in the 3D model or on your side? Intel FX, it's in the 3D model. It's in a piece called the Cockpit object. The 3D, the click spots are literally a piece of geometry that Gordon has to place, and I think he's messed about with the overhead and shifted everything back a little bit. Actually gonna, you know what, this is kind of annoying, so I'm gonna go ahead and quickly figure out exactly what happened here. Hit show, and I'm gonna take a quick look. So that is changing texture coordinates. That's not it. Yeah, show this one. Ah, yeah, that's a lot of changes. Yeah, I know. Okay, I guess we'll keep this for now, and I'm gonna get this fixed later. So we're at a working prototype now, pretty much. And yeah, I added pixel effects to the ISI as well, so you can see the individual pixels there on the screen if it let me actually make it too large. So that is there as well. And also shows up obviously. Also obviously shows up when you come in real close like this. So yeah. Hey, Reflective Reality Sim, how are you doing? Anyway, so what I wanted to show you here is we have altimeter temperature effect simulation, right? So when you are, there are two aspects, I guess. Yeah, let's show it like this. I think I've already drawn this, but I can show you again. I can show you again by jumping in like so. Let's go full screen. Okay. P for brush, I think. So here's the problem with altimeter temperature effects, or why they even happen in the first place. I'm going to minimize you. If you are, you're familiar with your pressure altitude diagram, which looks usually something like a wider brush here. Yeah, sure, that one will do. So we'll make an XY graph, which of course is the only proper way to show anything in reality. So your x-axis here would be your true altitude, right? So we'll call this ALT. And over here on the y-axis, we got air pressure. And so let's see, this would be, you know, whatever, you know, 0 meters or 0 feet or whatever. We can call this, you know, mean sea level. Up here would be something. It's just altitude increasing, pressure like that. So your conventional, where's the damn pen? I hate this new style. Everything goes to the like subdued monochrome controls. I have absolutely no friggin' clue what is. I miss the old times when I can actually understand what functions are. Anyway, ranting and ranting. So your altitude and pressure curve usually is depicted as something like this. Yeah, I'm gonna pick a different pen color. And we'll make a stroke along this thing. That's like, I don't know, this wide. So this is the conventional way that a pressure and altitude diagram is depicted, right? So this is what your altimeter is calibrated to. So there would be, I don't know, this we should call the ISA curve, the International Standard Atmospheric Curve, which gives you for a given altitude, what is the pressure going to be? And pressure is what your altimeter measures, and it then converts it over effectively to an altitude reading for you. Now, you are all quite well familiar that this is a fairly non-complicated subject, or a fairly common thing to know amongst flight simmers is your QNH setting or your barometer subscale. And so let's say be something like this. I'm gonna again grab a different pen color, and let's say that the sea level or for whatever reason the pressure gradient that day is slightly different, and it's effectively causing a different base value. And so this is what you normally adjust with your QNH subsetting or altimeter barometric scale subsetting. This is your change in QNH setting, right? So this is what you set on your Colesman window, QNH. This is all, well and good, but it doesn't capture everything that happens with the atmosphere. One of the problems is, or one of the complications here, that this assumes an isotemperature deviation of 0 degrees Celsius. So if I were to plot at every point along the altitude here, I also have not only a pressure, I also have a temperature, right? So at some altitude here, I would have a temperature Tx, whatever. Doesn't matter what it is, but it would be something. The problem is that not only does your pressure gradient, so this is called the pressure gradient, not only is the pressure gradient changed by the sea level pressure or the effective, local pressure, absolute atmospheric pressure, it also is changed by the temperature. And here's how it is changed by temperature. Make a different colored curve. And I select just you. Yeah, just you. And so here's what a difference in atmospheric temperature would look like. And let's pick another color, something like that, sure. And this would be essentially sort of assuming that, I don't know, we've got a slightly higher QNH. So we would be setting, theoretically we could be setting our QNH higher, but what this causes is that now the curve slope has changed. That's the different temperature effects. Red and green, that is different pressure effects. And the purple here, that is caused by a different temperature gradient, or a different base temperature of the atmosphere, which causes a different pressure gradient. You have no way of compensating for this directly in the altimeter. Your altimeter does not know about this. So how do we solve that? Here's how to solve that. I've kind of been lying here. This is not actually QNH. QNH is a somewhat fake value. It's not the sea level pressure. Anytime somebody tells you QNH is your sea level atmospheric pressure, that is a bit of a lie. Really what it is the pressure differential from standard to a fictitious, let's put it like this, to a fictitious base point, such that a standard rates or standard slope curve would cross over at your field elevation. So let's say our field elevation is here. So to get and we have a certain temperature, we have a certain pressure, right? So a QNH would actually be, if we just took the green curve here or the red curve here and projected it back, your QNH setting would be this differential here. So it's essentially tricking your standard calibrated altimeter to show correct altitude at the airport elevator or at the station elevation where that QNH was constructed. At this face palm. Yeah, no, it's just I'm sweating. It's a little bit hot here. Anyway, so this would be your station elevation, and the way to get a barometric altimeter to read. Yes, it'll read correctly at the station, at the airport, but you'll notice that the altimeter will keep on thinking essentially that the curve continues on like this. But it doesn't. In a different temperature environment, it will actually continue to either be slack or a little bit too high. And that is what causes your temperature variation or your temperature compensation requirement in an altimeter. Now, altimeters conventionally do not have a way to enter a temperature compensation. You'd be just doing it all the time if you had. So the way to work around this is generally we just don't. We just accept that there's going to be some true altitude variation from what you think you are flying at, but because everybody else is flying in the same atmosphere and they're using the same type of altimeter, therefore everybody's going to be wrong by the same amount, so we're not going to run into each other. But the problem is, we go back into the simulator here, the problem is Pilot Edge, VATSIM, IVAO, none of these guys correctly implement that. They don't understand the difference between barometric pressure and or barometric altitude and true altitude. Happy time for your watch stream. Yep, cool. Thanks, Monty. So welcome, Monty. So if we were correctly, and so in the CL650, I do simulate that temperature effect. In fact, I implemented a whole new atmospheric system to simulate that. But if I just use this while we were flying online on networks that do not understand this, you would appear to be either too high or too low, depending on whether the ISO deviation is plus or minus, and it would vary quite considerably. The standard rule is 4% for every 10 degrees Celsius of ISO variation above field elevation. So if we were, say, flying at 35,000 feet and it was 10 degrees hotter, then we would be 4,000 feet. We would be 4% of that 35,000 feet, which is about, give or take, about 1,400 feet higher than true elevation or true barometric or essential geopotential altitude is the correct term. So how do we work around that for these online networks? Really, the only way we can do that right now is we can either ignore it and you'll deal with it when the problem arises, or you can temporarily disable the temperature effect simulation while flying online, and in that case, it's just not going to apply the temperature effects at all. It's always going to match your true altitude no matter what. That unfortunately kills an aspect of realism, also destroys or completely obviates the need for this subsystem. So the temperature compensation subsystem is also going completely out the window. Now that's boring, and for offline flying, we never do that. You always have the temperature system on functioning while flying offline. However, online flight, I understand people are going to get annoyed by this, maybe. And if they're not willing to deal with it, they can just go ahead and kill the simulation system for the temperature while flying online. Your choice. I'm just going to keep it for myself running, and I'll just deal with it with the controllers if they ever, if they ever have a problem with that, I'll deal with it. So, long story short, why I'm keeping that feature online. So, I've got the flight plan more or less in place, roughly thereabouts. I'm gonna grab you, and I'm gonna actually go to Pilot Edge. I'm gonna file up my flight plan here. Just a sec. Pilot Center. Where's my file and flight plan? There you are. So am I still connected? No, I'm not. I'm gonna go ahead and connect. Yes, keep the system on. And you can, if you always want to have it on or always want to have it off, you can just check the checkbox and it's not going to ask you anymore. It's actually only going to ask you if you keep it on. So I'm November 650 Charlie Lima. I am type CL650 and I am Land Lima. Yes, GNSS transponder mode CRVSM capable, 1 aircraft, definitely not heavy. And what is our true airspeed going to be? Actually, I'm going to fire up SimBrief here just momentarily. Do I actually have a current database in the thing? I think I do, don't I? Status. Oh, yeah, just barely. But we do. You can actually, or I can actually switch. I can switch databases while the sim is still running. The airplane is capable of doing that. Just gonna call myself that. I'm gonna go from Palm Springs to San Jose. Yeah, whatever. We're gonna depart at some point. Everybody wants me to fly that. Yeah, sure, let's fly that. Who gives a crap? I don't need that, and that. ETOPS planning, definitely don't need that. And let's go generate OFP. Sorry for gonna throw in some people in here. 900 pounds of payload. So I'm gonna go fly from. Hey Sparker, how are you doing? Rock and roll. Go ahead and file it on the pilot edges, the edge of all pilots. IFR, I'm going to be November 650 Charlie Lima, type CL650 474 Palm Springs, remark SimBrief. No, we don't need that remark. 40,000 feet. Sure, why not? We can go up to 40K. And we're not using any of that. Good stuff. Sacramento is going to be our diversion airport. Lovely stuff. How high can a CL650 fly? Flight level 410. So 41,000 feet is our limit. Good stuff. So I'm gonna put you away for the time being. Hey, Astra V2. Cool. So, cabin's gonna be toasty. Yep, it is. 62 degrees in here. That's not Fahrenheit, dudes. That's the other type. All right, I gotta hit the click spots here. Where are you? Damn it. No, not that one. Not that one. Damn it. Show me the click spots. That. And that. And that overhead is going to get annoying. Fortunately, I don't have to manipulate it too much while en route. Let the tech route search. Hey, Amy in orbit, how are you doing? Just 410, yes. Alrighty. Poo is available. Nope, not that one. Okay, now to find that click spot. Sure. Take your ground power. Not that button, the other button. That button. In fact, we can turn on the isolation valve here, sure. Normally you'd wait 2 minutes, but sure, whatever. Hey, Fokker, 70. Yeah, Fokker 70. Gordon did a number a little bit on the overhead, and Does the CL650 the 60 compensates for change in pressure or temperature, and does that not cause a problem IRL with planes that don't? War cake. Maybe turn on tooltips. Yeah, I suppose I could. Yeah. Instrument descriptions. Hope we got tooltips on there. We don't? Okay. Well, I'm gonna have to have Goring put tooltips in there as well. Anyway. War cake, so the way you normally do it is in real life, you don't compensate while en route. Because generally it isn't a problem. And on the approach, the CL650 has a system in here in the FMS that lets you adjust approach altitudes. I can show you how that works. Let me just grab the flight plan. We can do it over here on this one. Data link. And we should have link. Just go to link status. Yes, we are online. So we would go to, actually not data link, we go to route menu, flight plan recall. And from Palm Springs, SJC. No, it's not adjusting throughout the whole flight. That's one of the problems why it doesn't, is because if everybody else isn't doing it, they don't, then we wouldn't be able to do, everybody would be flying at different altitudes. That'd be bad in reality. Cool. Request pending. Oh, that was a fast retrieval. Thank you, VDL mode 2. So Palm Springs to SJC. Activate. Execute. And if I go ahead and I'm going to just throw in an approach into SJC to show you how the system works. Other planes have piles with tables and calculators. That too. Yes, they also have tables. So let's just go, I don't know, let's pick an approach. It doesn't really, from board, because I'm bored, sure. You'll see now it says check airport OAT. That's because it thinks that we're near the approach or we're on the ground. So we need to go ahead and enter we're in the terminal maneuvering area. So we need to enter an airport or pressure or temperature target. So let's do that over on CDU2. So I'm going to bring you up into here. Notice all these altitudes here are just saying 52, 4,000, 2,700, blah, 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 blah. If I go here into temp comp and I'm going to select SJC, I'm going to punch in what is the temperature currently at SJC. I can actually, let's bring up the third CDU here because we can. Go at ATIS KSJC. Send an ATIS request. That was fast. So, as you can see, notice that I am currently on Pilot Edge, so it automatically fetches the Pilot Edge data, Pilot Edge ATIS for me. Now, not all that hot. So for now, I'm just going to simulate that it's very, very hot at SJC. I'm going to punch in 35 degrees. Going to ask me correct approach altitudes down, because when I'm at a higher temperature than normal, that or ISO plus 20 here, that will mean that I need to fly at a lower altitude to hit the same geometric true altitude as normally. How does the CL650 get around a requirement? It's not permitted to alter any altitudes on a star or approach. Well, Scarebus driver, you are... this would be something a company would give you. So, go like that, and now you'll notice it says this little copyright symbol on there. That means that we are now operating with temperature compensated altitudes there. OYS 2000, welcome aboard. Airbus driver, it comes down to whether your company is authorized to do that, and for example, a lot of companies will not let you adjust OAT positive. So that's why the thing even asked me whether I want to do this. Now, if it was like, I don't know, -10, it's not even going to ask me whether I want to adjust the altitudes up, because that is generally considered a safe thing. Adjusting upwards is more safe than adjusting it, you know, than adjusting them down. You can also go ahead and completely disable the system, in which case it's never going to ask you, never going to bother you. And you can also go into defaults here. And if you completely disable temp comp, temperature compensation, then it's never going to activate on any flight plan that you have. If your company was not authorized to use temperature compensation, you would have this set to off and you'd never worry about it. Or alternatively, if you're flying into an airport where temperature compensation is currently would be positive, so you'd have to go in positive or adjust the altitudes down. It might start annoying you that it's gonna ask you about check airport OAT. Then you could just go ahead and for that one flight disable the system, and it's never gonna bother you. So it's there. It's a tool. It's available to you. If you want to use it, use it. If you don't want to use it, don't. So, however, what I'm gonna do. Hey, Captain Crash. Welcome. I'm gonna go ahead and kill that approach. I'm gonna make that message go away. Not modifying the altitude on Airbus is because it breaks the coded angle between waypoints. Not a problem with the CL650. Oh, interesting. I didn't know. Cool. Now then, let's go make another ATIS request. Palm Springs. Just take a look. Data ATIS not available. Huh. Well, not going to worry about that then. But what we can do is we can go ahead and make a terminal weather request here. Palm Springs. Received. Damn, this VDL mode 2 is fast. So Palm Springs variable 6, 2996 on the altimeter plus 29. And TAF is unremarkable. So, that out of the way. I'm gonna go ahead and do a quick set of adjustments here. We actually want to switch you over into 8-inch mode. 2996. I currently have it enabled such that the left and right systems here are synchronized. So if I adjust the altimeter on the left, it's also going to adjust on the right and vice versa. But you'll notice what doesn't change, it doesn't synchronize, is this guy. So this guy is independent of the main avionics. Well, I mean, both sides of the avionics in reality are also independent of each other, and there's no such thing as linking these together. It doesn't happen. Real avionics doesn't have that, but for convenience sake, yes, the ISI is in. But for convenience sake, you can have the left and right avionics synced up, but your ISI is never going to sync up because that's always a separate action that the pilot flying's got to do. Is they got to go ahead and set the correct barrel here, and then also set the correct barrel on the standby system. On the Airbus, you cannot touch anything with a coded descending. It will not permit it, as Graham says. On the Boeing, we cannot do it either. Breaks the cutting for the final descent path, i.e. minus 3.2 degrees. Could be that. No. This is different. Scarebus driver, you're thinking about it like a Boeing or an Airbus. This is a built-in feature of the FMS. Is it possible to change the runway length if you're doing an intersection departure? I know in the US, not that common. However, in the UK, we love it. James, you can, of course. I know you're not up to that section yet. What do you mean? I am up. The FMS is essentially feature complete. Scarebus driver, this is a different feature from just going in and manually punching in new altitudes on the right-hand side here. This is a native mechanism that the FMS is built to do. So it understands when I make a temperature adjustment here. Just going to reselect another approach just for funsies. Yeah, whatever. Going to reselect another approach just so we got something here. The FMS understands. I get it just saying on bus and Boeing. Okay, we have no temp comp. Or no mechanism to alter the altitudes. Yeah, perhaps. In that case, you might be, I don't know. I know some companies provide like different charts for high low temperature operation, and maybe they have company specific procedures to deal with that. On a Challenger, you got the avionics that can actually take care of that. Your current stage of flight, that's cool though. Awesome work. Yeah, so James, you might be thinking about it again in terms of like an Airbus. On here, we don't. Yeah, if it has temperature compensation charts, could be. On here, as far as runway length adjustments go, the only thing that really matters to us, James, is performance stuff. And the performance calculator here is perfectly capable of selecting whatever runway length you want. So say for instance I'm taking off 3-1 left, Cathedral 1, yeah, sure, whatever. And you'll see it automatically picks up which runway at my departure airport, automatically picks up the runway length, slope, and everything. But if I don't like any of these parameters, I can just adjust them. So if I want to take off 2,000 feet off the end here, I just punch in 8,000, and that overrides the FMS provided runway info. If I don't like the slope data here, I can go, okay, it's not up 0.7, it's down 1.2 on the runway slope. Now that all modifies the data that the FMC here uses to compute any V-speeds. Now currently I don't have a V-speed in here because I haven't punched in a temperature. That is also required, so if I punch in a temperature, you'll notice now it does actually populate the V-speeds. So I could send these over to the to the panel here, and it would basically work as is. If I don't want my runway length this way, I can revert it back to the defaults, or I can even punch in a different runway. Say for instance, I didn't get runway 3-1 left, I got 1-3 right, so the opposite direction. I could go 1-3 right, punch that in there, and it automatically picks up. It's basically a full, as you're used on your EFB, you'd have like a performance calculator thing on the side. This is all built into the FMS directly on a Collins system, so you don't have to basically have anything. In fact, it even computes runway winds. So I'd say, if I had like, we're required to check the altitudes. If don't match, we can't do it. You apply manual adjustments, then fly semi-manual as opposed to the fully automatic system of CL650. Because in many countries, you're not permitted to change any altitudes in a database of populated value. Ah, cool. Yeah, well, James, just one quick note here. It even automatically compensates wind. So say, for instance, the wind was 240 at 5. I can punch that in here. Automatically computes the head and tail component. And if I reverse the runway, it automatically reverses the components, obviously, because I can recompute from the exact wind. But if I don't want to put in, I've put in a custom runway, it doesn't know the direction at that point. So if I put in a different runway length, then I'd have to put in my own wind either over here on the left, basically into runway wind component. And even funnier is, how do you enter, as you saw earlier, if I look on my data link stuff here, ATIS, no, not ATIS, that was in terminal weather. So weather view, Palm Springs said we got variable 6 knots. Conventionally, does the Challenger support GLS approaches? No. Bottle. Another case of the technology evolving before the regulators understand it. A great system way to the future in RMP approach, reducing altimeter errors and also correction errors. Does the CL650 have some Proline as a CJ4? It looks quite the same. Woozleman, very similar. It's a Proline 21 Advanced, not a Proline 21, but I think they've actually are simulating that in CJ6, so it's a similar system, very, very similar. Proline really is an umbrella term. That is more of a set of products that Collins sells, and it's the individual FMC components and the screens and everything that actually are the meat and potatoes of the system. What was I wanted to say here? Right, variable 6. A lot of operators will want you to enter that as a tailwind into your calculation. So rather than entering, something like VRB6 here, it doesn't understand that. It's just going to go, what? We just enter tail 6. And that's it. It automatically now assumes whatever the runway direction, doesn't matter. I can even enter my own runway length. it still assumes that we're going to have a tailwind of 6 knots for the V-speed computation purposes. Yes, it doesn't have a GBAS receiver. We have an S-bass receiver, which is also fully simulated to the point of my neuroticism. So yeah, we are actually currently in WAS service coverage. We are S-bass precision approach able, and we've got a horizontal and vertical protection level that are actually pulled in real time directly off the network, off the real WAS network. So let's see. So it's essentially we're pulling data that is displayed on this chart directly into the simulator. As soon as you enter a custom runway like that for an intersection departure, the automatically disables, and you need to compute your own head and cross components. Yes, Intel FX. I don't know why they did it that way, but that's how the thing behaves. But you can easily do it. If that is that much of a problem, you can just do it in sequence. So 250 head 2. So just copy head 2 in here manually and then adjust the length. And there you go. Actually, I wanted to take on some fuel while I'm sitting here and yapping my face. Errors reverted. Never mind that message. That goes away. Cool. Actually, no, that's not what I wanted to push. I'm going to come in here. Actually, do I have geopolitical terrain enabled? Yes, I do. Cool. Neat. So I wanted to take on some fuel, because I ain't got much in the tanks currently. Cabin's nice and chill. That's all good. Go ahead and go into refuel. Call up the interior refuel panel. And also call up the fuel truck. And how much fuel do I need? Normally you would do this actually properly, but I'm just sort of going to mess about with it. This takeoff fuel, block fuel 2.4 tons. So 2464 times 2.2, 5,400 pounds. For simplicity's sake, I'm just going to take on 6,000 pounds. Currently have 2130 roughly in there. Now, keep in mind, this value is there's sensor error. You know, you see it's kind of fluctuating. It can be off by a few percent. You know, don't take this number to be gospel. If you really wanted to know the exact tankage state, you'd go and dip tanks and do that, all that kind of good stuff. Nobody really does that, so that is why it's always a little bit of, you know, fudge factor with fuel values. You never trust your fuel metering system. It's never 100% accurate. Good. So to that end, and this is actually let's see. Actually, I can look at the true tankage state just because I've got my little debug screens here. And says our true tankage state on the left is 1102. We are measuring 1080. 1138 on the right, we are measuring 1050. So this is overreading by 10 pounds. This is underreading by about 20 pounds. Not too bad. We're within about a percentage point. This is a good time, but as soon as the airplane starts moving about and jostling about, that value is going to jump about quite a bit. So to that end, better take more fuel than you need than not enough. Yes, exactly. Yep. So, has been asked before, will we get the option to change? Yes. Yes. It's up in one of these menus down here. I'm actually going to pull it out into probably user settings here somewhere. Cool. Let's see. How much fuel do I need? I'm got about 2130, so call that 2000. I want to get up to 6000, give or take. That is going to be 4,000 pounds. So 4,000. What's the fuel density today? For that, normally you'd talk to the fueler guys, but I'm gonna just take a quick look over here. 6.7 pounds per gallon. So 71. So we need to take on 596 gallons. So that's the funny part is the fueler. The fuelers always operate in volume, right? Because that is the only thing that you can accurately measure on a flow meter is volume. It's essentially the amount of displacement on like a bunch of little veins that's moving. That's a very accurate measurement. You cannot measure mass accurately anyway, not while you're pumping it. You can measure it by putting it into a known tank and then measuring it there, but that's just not a flow meter. That'll be extremely slow. Yes. You can also distances in meters. Yes. Also, you can actually set. So I currently have the takeoff calculator here set to feet. Now the airplane understands. Don't worry about it, Goran. It's fine. Just a little bit of extra hilarity for me to work around. I thought I'd fix this. Don't worry about it. Maybe I don't know. Maybe I've botched my build. Who knows? Anyway, so the airplane, even though it might be, so here's the thing about pounds for fuel, kilograms for fuel. Actually, I might have broken it myself, or I haven't actually refreshed the build currently. So Gordon, don't lose sleep over it. I'm gonna fix it later on when I land. Cool. So let's see. What did I think about doing here? Right. So even though the airplane is sort of from the factory for you preset either for pounds or kilograms, your runway lengths can vary based on which country you're flying in, right? So you could be in Europe, in which case you'd have runway lengths in meters. You could be in the US or Canada, in which case you'd probably be in feet, or Canada might be meters already. So anyway, easy way to switch those is just punch an M and throw it in there, and there you go. Now you've got everything in meters, and it even preserves it across here. So if I go ahead and I've only got 2,500 meters, it preserves the unit for you. So that takes care of those cases. Or if I want it back in feet, I just put in an F and there you go. All right, Canada's in feet, cool. I guess for compatibility's sake. And you'll notice it also pulled in the EFIS barometric setting. So I got 2996 here. And if I adjust the barometric setting over on the EFIS, it automatically is transmitted over to the FMS as well. In fact, it even calculates the pressure altitude at my field here. So if I change, for example, the temperature, it will, not temperature, it will change if I adjust the barometric setting for the airport. So if I had a very, very low pressure, then it's effectively as if we were at a very high pressure altitude. That is for performance computation reasons, because the performance tables for the aircraft are calculated in pressure, altitude, and temperature. Cool. Now, what is it that I wanted to set here? Right, we want to put on 600 gallons, right? So the fuel truck guys always want to have it in units of volume. Now, you could just hit start and fill her up all the way, but since this aircraft doesn't have any kind of tankage preset on the refuel defuel system, you can't preset a volume. What's the dashed yellow part on the altitude tape? That means I've got no altitude pre-selected currently. That's the way the Avionics always boots up into it. It has no altitude target. How do you properly do it properly without looking at the debug panel? So Intel FX, you could either use a standard density, which for Jet A, Yeah, which for Jet A in the US is 6.7 pounds per gallon, or you would normally get a fueling sheet from your fueler, and they would tell you what the fuel density is on that day, because it will vary not only by temperature, but also vary quite considerably based on what type of crude oil or whatever fuel supplier was using with the refining process did essentially. Yellow part under the altitude reading. Yellow part. That is your radio altimeter. So this basically means I'm 0 feet above ground. If that's what you mean. So let's say we want to only put on 600 gallons. I've currently got the thing set in gallons here. I'm going to make it such that in Europe and everywhere else it's going to be in liters, so that's going to add some extra hilarity to your endeavors for fuel volume conversions, an extra challenge which real pilots have to deal with. Oh yeah, sure. Actually, cold stuff. Thank you. RGE zone. Yeah, perhaps. Okay, so we're just gonna go ahead and hit preset here. While it's blinking, I can use the plus or minus. Pre-select the fuel quantity. You can make a pretty close approximation by using 100 pounds per 15 gallons, which works to 666, whatever. Yeah. That was actually way too much. I just want to put in 600 gallons. So it accelerates quite severely. Hit enter, locked in the preset, and I'll just hit start. My pH is all in USG, all the pumps are in liters. Oh, that's lovely, Winston. That's always great fun. So I've got the pump running here, and if I bring up the debug view, you'll see that now the refuel defuel truck, if I go into the refuel defuel channel or part, you'll see that now the pressure refuel defuel port is applying 44 psi differential. So the pump is essentially now trying to put fuel into the aircraft, but I've got all the valves closed. Oh, thank you. Got some cool to drink. Thank you very much. Flying 152s in the US is interesting. Gallons and liters. Yeah, I can imagine. So all the refuel defuel valves are currently closed, so we gotta open them up. So we'll go ahead and fire up the refuel defuel panel. We can go ahead and do a lamp test here, make sure all the little lighty lights are working. And then what we do is we open them all up. 1, 2, 3. And we'll do a shutoff valve test. Check that all the high-level shutoff systems are working. And so with all that done, we can just go ahead and close the tail and the aux here. And we'll just let all the fuel flow into the main left and right mains. We should probably, let's see, 4,000. Yeah, we'll just take fuel into the mains here. I've only used the little brief moment here of letting it flow everywhere to do the quick shutoff test, and then I basically switched it off and let it go back into just refueling the main wing tanks. And you'll notice there's quite a bit of lag here. We've already taken up quite a bit of fuel, and it's still slowly going to count up. Actually, I mean, you can see this is basically the same indication because it's all coming. These numbers here for the fuel system are the same as what you see here because they are both coming from the fuel computer unit. In fact, this panel itself is directly controlled by the fuel computer, whereas this here is the electronic flight information system, the EFIS, and that one's receiving data from the FSCU over a serial bus. For extra irony, cool. Get the ramp guys to top off the tanks every time. Can't be bothered. I mean, sure, if you're flying that kind of aircraft where you can do that, that's all cool, but you don't, for bigger jets, it gets kind of a little bit less practical. I also got pop-ups for the clock here, which you can, I probably showed you, but we can actually do funny stuff, like I can switch over to, let's see, so I've got, you know, let's say I don't have a GPS source on the aircraft, this clock is actually fully capable of operating in full offline mode, no GPS source or syncing at all. And so to do that, you would have to set it, right? And you do that by switching it to whatever display you want, then hold mode. And now you can actually set your clock, and the thing actually keeps track between your sim invocations. Like it's set it actually to real time. Should be 157. Yes, confirm, and there we go. So now we're running in UTC clock here, set to real time. Where I could just go ahead and switch it back over to GPS, and I'll immediately resync if it has a GPS lock. But this is going to show, in that case, it's going to show a simulator time. Yep. Putting on fuel, putting on fuel. In fact, what I'm going to do is I'm going to, just prior to completing the refuel, or I guess, we could put on a little bit of extra in the right-hand tank, because that is where the APU is pulling fuel from. And while we are here, we already got the flight plan loaded in, but I'm going to go ahead and go into perf in it. We've got 5 people on board. I don't know, 100 pounds of bags. Not 1,000, let's say 100 pounds of bags. And I'm going to manually put in. Now notice this number here, the calc fuel, is independent of whatever's shown here. That's because this is the FMS fuel state. That is essentially locked in, stored in the FMS itself, and each of them actually independently. So each of these guys has their own fuel state. They usually will be in sync, but don't have to be. Each of them integrates the fuel state on their own. So if we go here into perf init, this guy's got, you see, there's just a slight discrepancy between FMS1 and FMS2 on the calculated fuel state in the aircraft. And the more you fly, they can actually kind of drift a little bit out of sync. This one's in agreement with FMS2. And so normally what you do is you'd put in whatever you thought you had on board the aircraft in here. And the way this number is then updated, so put that in, manual 6000, that syncs it up with all the other FMCs. So they all crosstalk the new value to each other. And so now it's see it went from manual fuel into calc fuel, and calc fuel means that the FMS now only sums up the current fuel flow, which it has fuel meters for. So if we go to perf menu, fuel management, second page, it actually has the fuel flow meters linked up to it, and it basically takes this number and multiplies it by the amount of time that has elapsed since, it does it in about 5-second increments, and then that value gets subtracted from your FMS fuel, what it thinks is on board the aircraft. Why are the flow meters in mass units? Oh, strange, isn't it? They basically are using a kind of standardized measurement. So yes, there is a slight amount of variation there. Fuel management. There we go. Yeah, they're basically taking a rough guess of the fuel mass. So this is actually a volume meter in IntelliFX. Strange as that might sound. This is actually a volume meter, but the FMS just uses a standardized fuel mass of, I think, 6.7 pounds per gallon, and just then uses that to derive the value. The other way to get a fuel value is to delete the fuel value and then use the sensed fuel. Yes. I'm trying to show them how to do it properly, but improperly would be to go ahead and delete this, and then it would use the sensed tankage state here. But the proper way to, the sort of correct way to do this would be to use the, to basically put in manually how much you've got on. Actually, what I'm going to do here is I'm going to go ahead and create a new preset of 10 gallons for enter. And I'm going to close the left valve here, and I'm just going to put on an extra 10 gallons into the right tank. And pump is shut off. There we go. And it's just trying to basically alleviate a little bit of the fact that the APU is consuming out of the right tank here. I'm going to put in a little bit of extra fuel in there. Probably should have put in more than that. This will only be about 70 pounds, and I've already consumed more than that. Let's put in another 70 pounds. You'll see the valve. As soon as the pump shuts off here, these valves are pressure actuated, so they need actually tanker pressure to open them. So as soon as the tanker stops pumping, this valve's automatically going to slam closed. That's a safety mechanism such that in case you forgot all of these switches on, except for these guys, these are slightly different, so I'm going to discuss them a little bit later. Even if you forgot all these switches on and just departed, the valves are not going to stay open. As soon as the tanker stops pumping and disconnects, those are going to automatically close by spring. Or you're supposed to actually close them manually and shut down the panel, but in case you forgot it, it's making sure that it's not going to be, you know, fatal or something. The tail tanks here are a little bit strange. First of all, I'm going to show it like this. So if I switch this one on, nothing happens. If I switch this one on, nothing happens. If I switch them both on, you'll see that the tail's going to open. Can you leave the fuel caps off? Well, bottle in this case, no, not really. So why did the tail system open and none of the other ones? Because these guys are all pressure actuated, but these guys are not. The tail refuel valves are electrically, there's an electric servo motor there. And so in order to open them up, they don't actually need tanker pressure, they just need electrical power. We'll need to invent something else. CL650 rite of passage, yeah. So how do we solve in case, because when I show you what the fuel system looks like, in case anybody's not seen it yet. So this is the tail refuel defuel line that goes like this, and there's a protection zone in here which would normally stay closed. That's the rotor burst zone. So that'd be in case you had a rotor disc burst on the engine that could pierce the refuel defuel line. That'd be a bit of a safety issue. So normally there are two valves on either side that protect the airplane from ever entering that kind of a state. Or in flight, these should normally be closed. But if they're electrically actuated, you'll notice that they'll open up just fine with no tanker pressure. So what happens if you forget it? Yeah, forgetting. Oh, yeah. Thrust reversers for sure. Nose wheel steering probably as well, yeah. Because there's no lamp about it or anything. It's weird. It's just a switch. The only way to know is just using a switch. So how do you stop this from forgetting it? Well, the way it works is there's this pressure sensing system here. And if the fuel system computer unit senses no tender pressure from the tanker for more than 30 seconds, it will slam the valves shut and never reopen them. So we would wait for now 30 seconds. If I weren't an idiot, I would have started a chrono just to give myself a slight timeout or something. I didn't know when it would be the case. There's 10. Ah, there we go. So just about was yapping for 20 seconds. You see that they've now closed, and even if I try to refuel now with the tanker, they're not going to reopen. So what I'd have to do correctly now is you'd have to close them for about 5 seconds, and then it's going to let you reopen them. That's basically resetting the protection circuit back. Anyway, we got enough fuel on board. Get rid of you. Get rid of you. I'm still connected, aren't I? Yes, I am. I'm at Z signature. Let's do some checklists. How about that? I've got a text-to-speech system installed, so that should say something. It's going to talk a little bit weird, but at least it'll say something.
Flight compartment checklist. AC and DC electrodes.
Yeah, they're checked.
Nav lights, logo light.
Yeah, nav and... Oh man, these click spots are going to be the bane of my existence. So that one and that one.
Cockpit lights.
Intel FX it isn't. It's a stock system, or it's a stock thing that can be installed. It's an open source text-to-speech system That is just because on Linux you don't have anything else that comes built in with the operating system. Oh, sweet. Thanks. Let's go ahead and pull those. Thank you, thank you, thank you. Let's see if it'll survive. Oh, I'll probably have to restart the avionics, but it'll be fine. Don't worry. So let's go ahead and disconnect from PE for the time being. Gonna copy you over to you, I think. So go ahead and do a quick reload of aircraft and art. And the airplane's gonna be shut off, but never mind that. Has new mesh with weird texture, lower overhead. That's getting retextured organic stuff. Yikes. Hey, uncertified pilot, how are you doing? And yep. Well, not quite. Hang on. What? What am I using here? Which build am I on? Probably some sort of an idiot here. So it's over in X Aviation CL650 Dev. Aircraft. X Aviation. Take you guys along for the ride. CL650 Dev. Objects. Cockpit OBJ. That was modified just now. So I did pull it. Over the correct position. Also new mesh for lower overhead. Okay. Show stat. Okay. Right. I might need to pull in more. So overhead, everything OBJ. Throw it in there. Let's see. Give it a try. Yeah, don't worry. XP doesn't reload manipulators without a sim restart. Really? I thought it did. That'd be weird if it didn't. Perhaps. I don't know. All is well. I don't know. You moved the overhead. See, yeah, it's probably more a matter of like me not doing the rebuild correctly. So all is well. Thank you, Goran. Lovely stuff. I'm gonna reset my fuel to where it was. Fuel tanks. What was that? 2,000 or 500 before here, and 500 here. And I'm also gonna put in what I have for people. And we're gonna connect up to the PEs of the world. Keep temperature system on. Took about a half hour. Yeah. Something's wrong with the saves. No, Intel FX. I'm currently running a version that has it disabled. It can be enabled. I just don't have it currently in this build here. It's kind of stuttery. Might be. Oh no, hang on. I know why. There we go. Perfect. Good stuff. So. There's something different here as well. I think there's some placeholder mesh here.
Jet pipe overheat.
That's okay. I don't need to use these actually at all. They're just the miscellaneous test panels, and these guys are just usually. That's just some superfluous mesh. 2021 is the year. Yes, Sakura Hana, that is the goal. Let's get that APU cranking. Actually, let's go like this. All right, now you shifted the overhead panel. I need to shift my view here for the overhead debug screen, or the overhead, pop-up. Full stream ends up being testing model fixes. Yeah, we'll see. Exterior completed now. Almost complete, yes. Okay, you get the APU on the bus. So I am connected, good stuff. All of that is looking good. For I moved it back a bit. Oh, cool. That's fine. Yeah, I remember this part wasn't here before. I see you've got stuff you're working on. Yeah, there you go, folks. So stuff is progressing. The exterior is almost complete now, Sakura Hana. We've still got landing gear and some ancillary doors. The rough shape of the aircraft is more or less, there. It does look like a Challenger now. Which is usually a plus. Okie doke. So what did I want to do here? APU bleed. Yeah, normally you'd wait for this for 2 minutes, and you do your little timer check and everything. Poor guy here is realigning. Okie doke, that's all good. Get rid of this. Good stuff. So, my flight plan should still be in the box, which it is. Victor 386, Palmdale J6 to Avenal, direct makers, direct trucks. And we expect an arrival actually, so I can just go ahead and punch that in. And that was, at least I've got a file. Let's see if we get it. Silicon 5 via trucks. And just go ahead and quickly check. There's going to be a disco here. That's fine. Drop the disco, and that's all good so far. So go into Perfinite. You'll notice it memorized the fuel state, so it still remembers what the fuel state was from before. Now I've actually got to refuel it again because I've reset the whole thing. So go like so. And actually, I'll close the valves here because there's an order to this. Refuel truck. I'm going to go ahead and pre-select 600 gallons on the thing. That was too fast, too far. There we go. 600. Cool, good stuff. Rock and roll. And test all the valves. Shut off test. All's looking well, so these guys can go closed. I'll just leave it to refuel into the means. So, we got passengers, we got cargo. I'm going to reset this back over now. I'm going to reset it to 6100 is about how much we got on board. So, flight level 400 is what I've got filed up for the flight plan. Estimated fuel on destination is going to be 3,900 pounds. That's quite a lot, but sure, better have too much than too little. 2,000 pounds is our reserve fuel. If I had not enough fuel, so basically if the fuel was below the reserve, if I put it in like that, it's going to say check fuel at destination. I'm basically thinking that I'm going to be low. Cool stuff. Fuel flow correction if you want. a change in this. You'd normally go into the default, so default entry only is why it says that. And I can account for a little bit more taxi fuel use. So let's say I'm gonna, dawdle about. I'm gonna be slow today. We're gonna sort of mess about with everything. So we'll put in 400 pounds of taxi fuel use. Cool. VNAV setup. 270 Mach 0.77 climb, 300 Mach 0.8 cruise, 0.78 Mach, 300 knot descent. Actually, I'm going to make it a Mach 0.80 descent. We're going to be quick. 3-degree VPA is optimal. That's all good. So I'm happy with that. Now we got to set our altitudes pre-populated here. And yeah, rock and roll. Apples 400, and then a descent starts just ahead of Makers. And to go ahead and check on it, you can go like, let you refuel. I'm going to take you over to memory position 2, which I've got stored for the plan mode. Or you can, if you were just, in standard, you can just hit lower format, switch over to memory to plan mode display. And since I've got you over in plan mode display, actually I could show you on the right hand side here. We'll go into MFD Advanced, go to the 2 waypoint, and now we just step through the whole thing. There's our top of climb, Palmdale, Lando, Avenal, Makers. There's a top of descent just in front of Makers. It's a little bit hard to see because it's obscured by the waypoint name. And then Trox, Silicon, and Valley. Good stuff. So we're happy with that. Display menu. What options do I want on the MFD? Yeah, sure. This looks good. There we go. Alignment has completed, so it's starting to draw terrain. Rock and roll. Let's do the checklist.
Flight compartment checklist. AC and DC electrodes.
Bit loud, I suppose. Let me just turn it down just a touch. AC and DC electrics are checked.
Nav lights, logo light.
There we go. They're on.
Cockpit lights.
Set.
Lamp test.
We do a lamp test here. Pulling this switch forward and back and everything. And so this checklist here, by the way, guys, this is fully configurable. You can actually change it if you don't want this. This is a checklist that was graciously provided by one of our tester guys. That's the checklist their operator uses, but you can change it if you want. I'm going to show you how. It's not at all difficult. It's going to come in the airplane itself. So if you just go into the aircraft folder itself, there's an XML file here. And if we go ahead and open it up in a text editor, you can change any of these stuff here. You'll understand how that checklist format. Free pin is crazy good. Oh, well, welcome aboard, Heli Pilot 7 and Campus 608. Thank you. So you can change any of these items if you want. You'll notice that, for example, CPD, the TTS name here, that's text to speech. So that's what the text to speech says. So that, for example, it spells out CPDLC, but stuff like perf, it will say as a word, which is why it's lowercase. Even stuff that's a little bit weird, like TCAS, in order to get a text-to-speech system to speak correctly, you have to spell it as TEKAS, TCAS, rather than, spell it out in all large letters, because otherwise it would just spell it out as TCAS, which is dumb. So you can change that if you want, and you don't even have to edit the original file, because, if you updated the airplane, it's going to get rewritten. You can actually just go ahead, and if you've modified the file here, you can take it into simulator output CL650, and if you drop the file here, it would start being used by, it would start being used by the airplane instead of the one that comes in the airplane itself. So you can customize your own checklist if you want. Texas Pete and kept wondering why you're talking about hot sauce. Hey, El Promo, guten Abend. Okay, so the checklist here can be changed. So that's why this kind of weird symbol here, that sort of, caret, asterisk, and caret, what that means I asked him, what does that, what is this symbol, what's that for? And he explained to me that that's how they write checklist items that are only to be done on the first flight of the day. So, Toto speaking German. Yeah. So this is supposed to represent a sun, a rising sun, essentially. So that's why lamp test you would only do on the first flight of the day. Duct monitor check you would only do on the first flight of the day.
Duct monitor.
And I currently don't have the duct monitor implemented. It's over here. Still got to do that.
FMS database status.
The FMS databases, you'd go ahead and on the first flight of the day, you'd cycle the databases around to dump the old flight plans and everything and basically get the FMS fully cleaned up. Already got everything programmed, so that's it.
FMS flight plan uplink. ATs.
And ATIS is, well, we don't have ATIS here data, but for Palm Springs, but we've got the terminal weather, and I'm pretty soon going to listen to the ATIS just shortly.
Anti-skid.
Anti-skid is armed, but I still got to implement a test here. So there's a little test button.
Nose door.
That'd be, you'd have a guy standing in front of the airplane making sure that we can pressurize hydraulics. As soon as we flick on 3A hydraulic pump, you would have the nose door. If it was closed, it would immediately shut. So you don't want to have anybody, sitting there doing something with the nose door and having them have their fingers, slammed by the nose door.
Hydraulic 3A pump.
So fire up the 3A pump.
Brake pressure.
We check we got inboard brake pressure. That's all good.
Parking brake.
Go ahead and set the parking brake here. So pull that.
Nose door.
Again, they check that it's closed now if it was ever open.
Hydraulic panel and pumps.
Checked. We can set all the pumps over to auto now.
Electric panel.
That is all set. We actually have the AC/DC utility switch on. That would shed the galley if we were running on APU power. Any links published yet to the jump studying all the avionics systems? I currently don't have them in the center pedestal and pushed. Oh, lovely stuff. I'll get it after we land leading edge, because I don't want to be starting another flight here again.
AC/DC utility switch.
It's just on.
Start ignition panel.
That's all checked. Basically, make sure everything is turned off there
Fuel
currently.
panel.
And fuel panel. Well, that's fine. We don't need any of those.
APU LCV.
APU LCV is this guy. That's the low control valve, or APU bleed.
10th stage isolation.
That one's
valve.
open.
Packs.
Packs are on.
Air conditioning panel.
Air conditioning panel. That'll be this guy down here. We can set, whatever mode and temperature we want. We'll just leave them all sort of on normal, and the sort of this kind of an 11 o'clock position on the temperature, cabin temperature, and all that other stuff. Will give you about 21 to 22 degrees in the cabin. Currently, what are we running? 23. We might set that actually a little bit lower, although it's hot outside, so you don't want to, super cool everybody on board. Also, you want to make sure you got your ram air valve closed. So if the ram air valve is open, that'll take a couple of seconds to open up. Hey, Citation Max, how are you? Temperature transfer control. That's for where the cabin temperature is controlled, either from the cockpit or from the cabin.
Pressurization panel.
Press panel. Man, you removed a little card here. There's another piece of texture here that's a little bit borked.
Bleed air panel.
Bleed air is all good.
Supplemental ground wing anti-ice panel switch.
So that'll be this guy, either the test and the system off button. We want to have that out.
Cowl anti-ice switches.
Cowl anti-ice, we want to have them off.
Anti-ice panel.
Just check that everything's looking good.
Emergency lights.
We can arm those guys.
Passenger signs.
We'll leave them off for now.
ELT.
Is armed.
Glare shield panel.
Glare shield, just check that all the panels and all the lights and everything here is in the correct position.
Crew and passenger oxygen.
That's a thing I gotta implement, so that'll be your check your oxygen system and everything.
DCU warning panel.
DCU warning panel's all the way over here. That's this guy. we want to make sure we don't have any DCU audio inhibited, because that will inhibit, you know, your dings and your caution lights and caution audio messages.
CVR.
You do your cockpit voice recorder test.
Audio panels.
Audio panels will be these guys here, so you'd set up your audio however you want it.
SPS system.
This SPS system would be your stall protection, so that is under here. You want to make sure that they are both turned on, otherwise you're going to get, first of all, a caution here, stall fail. And it's also this guy here's got to be on, so both of them, both the stall protection, so this is the pusher. And you'd also do your stall system test, so that is down here. So there are, sorry, it's a little bit misplaced, these two switches should be over here. SPS test, so there are 3 switches here in a row. It's going to be left, right, and then you got a G relief switch, which you'd have to use 3 fingers for. All your panels look so retro to me. Yeah, they kind of do. And so if I hold, I'm actually going to bring up a little pop-up here, pop-up panel, aft pedestal. And they're both displaced over here as well. So if I show you like this, if I hold the test switch, this is both of them, I just want to have one of them. So we want to basically make sure that we've got the stick shaker running. I actually hit both of them, damn it. Damn it, just want to hit one of them. There. If I just test one, so only the left one's going to shake, right one's not going to do anything. And we've got ignition A and B on. Ignition A and B on. Same thing if I do a test on the right here only. Only this guy's going to go up. And we got the caution, we got ignition, all the good stuff. And if both channels agree, designed in the early 1990s, yeah. And so I've got a click spot here that sits in between these 2 switches, which lets you actuate both of them at the same time. You use 2 fingers for that. You hold, if both stall systems agree that we're in a stall, then you're also going to get the stick pusher. And there's a 3rd switch here. You'd have to bind a separate key to that. I might just put another click spot here to actuate all 3 switches at the same time. And what that does is, while the stick pusher is actuating, while it's operating, pushing your yoke forward, you can't actually pull it very, very far. It's very hard. The stick pusher is putting out a lot of pressure to get that yoke forward. And so there's a little G switch here that is to test an internal gravity switch inside of the stall protection system. Once you know, if you push fully forward on the stick, obviously the airplane's going to go, you know, nose over real hard. And so to protect, you know, to prevent the stall pusher or stick pusher from sending everybody in the cabin and flying up to the ceiling, there's a micro switch inside of the stall protection computers, which if it detects less than 0.5 Gs, it's going to relieve some of the pressure. And I do have it simulated, but I have to bind up a separate key to that, where it's actually going to relieve a little bit of that stick pusher pressure forward, so you can actually, you know, not get that much of a pushover forward. It doesn't send everybody to the ceiling. Okay.
Integrated standby instrument.
Integrated standby instrument. We just check whether, you know, thing is lit up, and we got the pressure set in and all that good stuff. Clock is on and synchronized.
FSICAS.
EF is in ICAS, so you know you check that all messages are explainable. Actually, I still got to fix that. There's some stuff on here that shouldn't be here, and stuff on there that should be there. Brett Skarzeks, welcome aboard.
Main landing gear bay overheat.
So there would be a little test here, and hang on, it's over here. Actually, I don't have that implemented currently, so we get a separate message about that.
TOS warning switches.
TOS warning switches. So these guys, we want to make sure that they are guarded and off. We could also do a TOS test. They're an override on the stick pusher too. Yeah, so normally you would do that by either mashing APSP disconnect, or you would kill it by flipping a switch off here. But yes, reflective reality sim. If you want to basically just kill the stick pusher, you'd hold the autopilot disconnect here.
switch and roll disconnect.
So those are these two guys. So these will want to make sure that they are fully stowed.
Ground spoilers.
Ground spoilers are in auto.
Thrust reversers.
Thrust reverser are off. Actually, we want to arm them now. We can go ahead and arm them, and they're actually going to come on here on the green lights. Also make sure that we've got the, the switches here. I'm just going to pull one forward. We want to have these guys down and back.
Thrust levers.
Check and shut off.
Engine speed switches.
Those are these two guys. These are your kind of electronic engine controls, and we want to have them on normally.
Engine vibration check.
That's the thing I got to implement. So that'll be you do a little vibe check here. You get a bunch of amber engine excessive vibration checks, alerts here.
Oral warning.
That's this guy here. Oral warning.
Smoke detector.
Got to implement that.
Trims mock trim.
Trims and mock trim. We want to make sure we can turn them on. Also yaw damper on. You want to check that you've got trim in a sensible position and everything moves. So all that good stuff. And you'd also check that you can interrupt it with your stab trim disconnect here. Yaw dampers are engaged.
Reversionary inhibit switches.
And everything over here is in normal, and lights are out.
IRS.
They're aligned.
CPDLC.
Currently not implemented. I'll get to that at some point. CPDLC.
TCAS.
You could do a TCAS test. Where's the test button for that? Damn it. All right, no, it's where are you? Is it in the menu? I forgot even completely where the TCAS system test is. It's over in here, right? I remember now. Tune. There we go, and we could do a test. We get our little lighty lights.
TCAS system test OK.
ATs and clearance.
Alright, we should probably talk to some people. So, get rid of you. And on here, actually, well, I'm going to go ahead and bring up charts. And where is your clearance? Palm Springs clearance 128.35. So tune 128.35. Hopefully got audio working. Preferences. And audio input, not this one. No, this guy here. And for output, I want you to go to here. Let's see if this works. Fingers crossed. Where's the call outs? What do you mean call outs? Yes, yaw dampers you to engage before start.
Figure to ground, number 1, kind far to Fraser Airport.
ECAS call out when testing. Did you not hear them? Let me check. Maybe OBS didn't pick it up. It did definitely call out.
TCAS system test OK.
There. That's your TCAS test. That's what it does. Oh, it doesn't do that. No. TCAS doesn't do... That would be for some sort of an extended diagnostic. Oh, no, hang on. That's for a different system. What you're talking about, a different kind of test. No, it's not like a Boeing where it does... Oh, you mean JITWIS test? TOS test? That would be done by pushing this guy here. We can do a 3-second, a short test. So if I bring it up like this, you'll see.
Glide slow. Pull up. Wind shear.
Wind shear.
No, those don't appear. Intel effects don't. Those don't appear during the test.
Right. Pull up.
Alrighty, let me
Departure frequency 118.
get some writing implements here.
Squawk 5172.
And I think you can hear pilot edge, so that's all good.
Okay, clear to Fresno Airport. Made a 4 departure and radar Victor to the...
How's the ATC volume, by the way?
Arrival. Maintain 3,000, about 8,000 after 10 minutes. Departure frequency 118.8. Squawk 5172. 19 mic. 19 mic, radar vectors tool. Alpha 9 arrival. Maintain 3,000.
It's audible. Is it loud enough? Not too loud. Not not loud enough.
3,000. 19 mic. I hear very broken. Sorry. Read that correct.
So here we are at signature. Good stuff.
Burbank Towers says 2 Romeo.
Could be louder.
Charlie,
Okay.
Clear, runway 8 at Delta 7.
Stand by. Let me readjust the volumes here. Turn you down. Turn you up. I'm going to turn the simulator down a little bit so it doesn't blow everybody's ears out. Let's see if this helps.
All right, 12 Romeo Charlie, where you parking?
I'll be parking straight ahead.
12 Romeo Charlie, Roger, taxi straight ahead to parking. This frequency pass for the Cat 8.
Taxi straight ahead for parking.
Oh, that's better.
Cat 8. Good day. Thank you.
We should be within maybe about 3 dBs of each other now with pilot edge. Good stuff. Do I have a button bound? I do. Yes, I do. Cool. We should get a lamp here when I talk. If I remember right. Palm Springs clearance. Good morning. November 650 Charlie Lima, IFR to San Jose.
650 Charlie Lima, Palm Springs clearance. Clear to San Jose Airport Cathedral 1 departure, Palm Springs. As filed. Maintain 7,000. Expect flight level 40010 minutes after departure. Departure frequency Departure frequency 126.7. Squawk 3262.
Clear to San Jose via Cathedral 1, Palm Springs. Then as filed. 7,000. Flight level 400 after 10 minutes. 126.7 for departure and 3262 on the squawk. November 650 Charlie Lima.
0 Charlie Lima, read back correct.
Hey, the Matthew, welcome. Okay, so they've given us all the little stuff we gotta punch in here. So 3262. Gonna go in there. We got clearance. We can continue with the checklist here. Get rid of this. I'm actually gonna turn off the ATC for the time being.
FMS flight plan, wind update, perf.
We should actually go ahead and grab the ATIS, right? Because I actually didn't grab it. So charts, volume ATIS or audio ATIS is on 12465. 12465.
F3. Visibility 10. Sky condition clear. Temperature 31. Dew point 19er. Altimeter 299er7. Arriving and departing runway 31 left, 31 right. Visual approach is in use. VFR departures contact clear and delivery. Advise on course heading, altitude, and if flight following is requested. Read back all runway assignments and hold short instructions. Advise on initial contact. You have information, Juliet.
Juliet.
Palm Springs International Airport. ATIS information, Juliet. 1553 Zulu. Wind variable at 3. Visibility 10. Sky condition clear. Temperature 31.
And we hear
Dew
the rest
point
there.
19er. Altimeter 299er7.
So that is all copied. Actually, you know what? I might have had the audio turned down just uselessly low. I'm gonna try and readjust it like this. Good. So we got Juliet. Gonna adjust the altimeters here. So 2997, 2997, 31 degrees. Go into perf, takeoff. 31 left, 31 on the temperature. And 31 on the temperature here as well. That's all good. All the other stuff here, I'm happy. Let's see. On mass, we have not changed anything. So cool. I'm just going to go ahead and send these speeds over to the EFIS. Yeah, it's all set up. We'll expect 7K. And what's the initial runway heading is 310, isn't it? Yeah, it's exactly 310. I'm just going to sync you up like this. Good stuff. Sweet. So with that out of the way, let's continue the checklist here. The first one is fairly long. The flight plan, actually, we can go ahead and pull the wind update on the flight plan. So go into here. It's under route menu, flight plan wind update. Go ahead and send a request. The data link is now fetching our wind update to our legs and everything. There we go. It's already pulled that in. Data link winds updated. So now we've got winds for the entire flight plan in here. Gonna make our fuel estimate a little bit more accurate. Not really that it matters for this kind of a short trip, but there it is. Good stuff. Continue the checklist.
Takeoff data.
Set.
Avionics charts.
Set.
Flight instruments.
Checked and set.
Departure briefing.
You know what we're going to do. No need to repeat it.
Emergency procedures.
This is communicating with ASXB. Rackamus, no, it's freezing real weather.
Pins, covers, chocks.
Pins, covers, and chocks. Chocks are actually still out, so we'll put those back in. I'm going to have to implement some pins and covers later on.
Cabin lights, water heaters, master seat.
That'll be cabin light crap. We'll let everybody else worry about that.
Flight compartment checklist complete. Engine start checklist next.
Cool. So, flight compartment checklist is all done. What do you guys think we go ahead and get underway and sit about here for a while? There's going to be a new ATIS in about 10 minutes. We'll see if we see it or fetch it and everything. Cool. Rock and roll. So let's get everything ready for the engine start. We, communicate with ground crew if anybody was around, make sure that nobody's gonna, get sucked into an engine, and we got doors closed and all that good stuff. So check you got no door cast here. All the other good stuff, fuel pumps, all the other good stuff is all explainable so far. So the only stuff that we got to do is put the beacon on, put the fuel pumps on, and we'll arm an ignition system here. What's the date today? The date is 11th, so we'll make it an odd start day, or let's do an A start here. Whatever procedure you want for alternating the starter system, the ignition systems is up to you, of course. Cool. Continue. So before start checklist.
Engine start checklist.
Engine start.
Doors.
Closed.
Park and brake and pressure.
Set and pressure is good.
Fuel quantity and balance.
Fuel quantity is 3,100 in the left, 3,000 in the right, and balance is good within limits. So it's 800. Let's see. It's 400 in flight, 800 on the ground, I think, for limits.
Beacon.
Beacon is on.
Fuel boost pumps.
On.
Ignition.
Armed. A.
Engine 2 start.
Okay, start engine number 2. Just halt the button here. Packs shut off automatically. And you start your clock and everything here for timing. I'm just sort of rushing through it. You'll do much better than I. Cool. Engine 2 has stabilized.
Fuel system.
Is all checked. We're looking good.
Engine 1's powered.
Looking for 25%. Yes, 25 are max cranking. Usually at least 20 is what GE requires. But yeah, 25% is good. Really the key is not a specific number. You're looking at that there's enough cranking pressure on the air turbine starter to get the engine over this hot hump here. Just between, at about 30% is where it's hottest. Alrighty, starter's cut out, so got off this ignition here. Get both generators online. AC and DC utility switches off. 14th stage on. All the other stuff here is looking good. Actually, we'll get the seat belts on so everybody's got their ass sat down. And let's get the rest of the checklist bashed out of the way.
Engine start checklist complete. After start checklist. Generator 1 and 2.
On,
Ignition.
off,
Packs.
on,
14th stage.
open.
Cowl anti-ice.
Cowl anti-ice is not required. Come on.
Flight controls.
You do your cowl anti-ice checks and all the other good stuff. Yes.
Ground spoilers.
Flight controls, you do all your flight controls checks. So go to flight controls and do your that and that. Good stuff. So ground spoilers are stowed all stowed auto.
Flight spoilers.
Checked and stowed.
Cowl anti-ice.
You turn that off. If you were doing you do a anti-ice test the first flight of the day.
Supplemental ground wing anti-ice.
Not required.
Fuel balance.
Fuel balance is checked. We're looking good.
Trims.
Trims are set.
Nose steer.
Is armed.
APR.
APR is armed. There's a test here for that as well. You could do if you wanted. So that one's already implemented.
ADG unit.
ADG unit test will be back here. This guy right there.
Supplemental ground wing anti-ice.
That'd be your looking for your
Cowl
test.
anti-ice.
Cowl anti-ice. Then you switch
Wing
it off.
anti-ice.
Not
14th stage isolation valve.
required. Isolation valve is out.
Wing anti-ice.
Wing anti-ice, you do again, you're checking everything, so you do like, let me see. I don't remember. Ah, there you go. So you do your wing anti-ice. That'd be your fail test.
Overheat.
Oh, there we go.
Wing overheat.
And then you've got your detection test as well.
ATS.
ATS, we should. Did I cancel you correctly? Right, 92 point that. Well, let's go ahead and deselect you, or reselect you. Yes, I know. Put you back in. Alright, no, I know. Being a bit of an idiot here. Takeoff. Compressor stages. 10th and 14th stage. I'll get to that in a sec here. I'm gonna resend my B-speeds back in. So the reason why it's basically a little bit unhappy about the checklist is asking me, I've got ATS set to N1 takeoff. To do that, I need to push the toga button here, and then it's gonna go into N1 takeoff. And I've got takeoff there. Then I'm gonna also arm LNAV and BNAV. We've got LNAV 1, altitude select, armed. Good stuff.
ATCT CAS.
that we currently want to switch over to Alt on, so push, push, push. So TCAS is on.
After start checklist complete. Taxi checklist next.
Cool.
Taxi checklist.
Ah, I didn't want
Taxi lights.
to push you, but you know what? We're gonna go ahead and, no, I'm gonna do this. So I'm gonna switch you over ICAS onto both PFDs. And then over here, I'm gonna bring up my charts. So I can, drive with the charts in view while the other guy's got room to, play around with his checklist and everything. And we're now gonna go talk to ground, which ground will be 121.9er. So 1219. There it is, all the good stuff. Just the new ATIS should be just about pushing out. Are we gonna listen to it? Let's just do a quick check.
Juliet, 1553 Zulu.
So still no new ATIS, but just about. Getting ready with that. So taxi light on. And I'm gonna call him for taxi. Palm Springs ground, Challenger 650 Charlie Lima at signature with Juliet, request taxi. Hope I'm talking to the correct frequency. Yeah, 1219.
Looks like we're Charlie with Palm Springs ground, runway 31 left, taxi via Whiskey Alpha.
31 left via Whiskey and Alpha, Challenger 650 Charlie Lima. Good stuff. So Whiskey Alpha, so that'll be basically, we'll shoot over here, Whiskey 3, Whiskey Alpha, all the way full length. Good stuff. So, parking brakes coming off. Actually, I'm going to step on the brakes here. You have, somebody looking out for you. That would be a marshaller, probably. So, brakes off. And does it need a little bit of juice? Yes, just a touch. And we'll hook her right here. Bring up my HUD. That looks like a taxi line to me. So let's follow it. About right. Continue the checklist. So the checklist item, the last one was taxi light. The taxi light's on.
Wing and cowl anti-ice.
Those are not required.
Brakes and steering.
Checked.
Reverse thrust.
We won't check.
If taxiing to de-ice,
Thank
pause
you.
checklist here until paper. De-ice checklist is complete.
Okay, so where do we turn here? Take Whiskey 2 or Whiskey 1 or Whiskey 3. Take Whiskey 2 here. So that'll be this guy here. Whiskey 3, and there should be Whiskey 2. As per usual, it wants to run away because the airplane's got a lot of power, not too much weight on it. So yeah, I keep having to mash a little bit of brake here.
Flaps.
Oh, I didn't set flaps for takeoff. What a noob. Classic X-Plane cars. Like having Stephen Hawking. Was that net Avio? Yeah, perhaps.
Altimeters.
Altimeters are 29907 and set and cross-checked, so we'd go ahead and check that we're both reading within error, and this guy's also reading within reason. I gotta set my speed here. So for ATS, I'm gonna set 200 as an initial speed target.
Radar weather.
It's not simulator currently.
Takeoff briefing.
Well, we do your takeoff briefing and everything. Pop a reverser. Yeah, I know, right? Let's do a little bit of reverse. Consider that our reverser check here.
Taxi checklist complete. Before takeoff checklist next.
Was it some kind of co-pilot he implemented? Or I just went back. That is text-to-speech, essentially. It's just reading these items off here, which again are fully configurable. So tower. Let's check. Tower. 119.7. So I'm going to preset you. 119.7. That goes in here in the second line. That's a preset now. And we're approaching here. We can do a before takeoff checklist.
Before takeoff checklist. Passenger signs.
On.
Anti-collision lights.
Those are going to be... Actually, I'll wait for until we've got clearance. So, swap over to tower. I'm going to hold short here so I can get a little bit organized. Just got a button here for brakes, so that's why it's looking a little bit tricky. So parking brake is set. Cool. So what did I want to check here? So we've got all of that checked, so I can swap over to our departure chart here. Just one knob to the right. Zoom in a little bit, and then that's going to be our route. So yeah, rock and roll. All up tower now. I'm going to switch you back over to the correct way around. Cool. Probes are coming on. Let's call them. Palm Springs Tower, Challenger 650 Charlie Lima, short of 3-1 left, ready for departure.
Charlie Lima, Palm Springs Tower, wind variable 3, runway 31 left, clear for takeoff.
3-1 left, clear for takeoff. Challenger 650 Charlie Lima. Rock and roll. Let's keep going then. So,
Probes.
probes are on.
Windshield heat.
Windshield heat is not simulated, but I'm gonna put it on low.
Wing and cowl anti-ice.
Not required. Approach sector is
Continuous
clear.
ignition.
Continuous ignition is gonna come on.
ATCT CAS.
That's clear over there. So now we would switch over to TARA.
Supplemental ground wing anti-ice panel.
Is off.
CAS takeoff config OK.
Just gonna line up here. It's a little bit fiddly here with no pedals and everything. So you got takeoff config OK.
Landing pulse. Record lights.
Those are coming on.
Before takeoff checklist complete. After takeoff checklist next.
Oh, sorry. I didn't want to bump that. Cool. Rock and roll. So, got brakes are off. Let's go, Mr. ATS. Get me to the moon. And we're looking for a power set of 92.3. That's about there. 92, 91.8. There's V1, rotate. Positive rate of climb, gears coming up. And I'm gonna put the autopilot on. Forgot to preset my departure here into 6.7.
So Charlie Lima, contact departure, see ya.
Departure, 0 Charlie Lima, see ya. Yeah, flaps are coming up. Pull it up to 210 here. So just swap it over. Locale departure, November 650 Charlie Lima, 2,600 kilometers, 7,000.
650 650 Charlie Lima, so departure radar contact, climb maintain 13,000.
13,000, 650 Charlie Lima. Boom. 13,000 is set. So, I'm going to give speed control over to the FMS. And we can switch it over to light level change mode as well. Time to do a PAX transition, so continuous ignition is not required. Close the ISOL. Open up the right bleed. That's all good. Close LCV. Have the left bleed. And climb is looking good. Also come in here, perf target, set the climb thrust. AP generator on, APU off. And actually anti-collision I forgot to turn on. Landing lights are coming off, and that guy as well. On with that out of the way, rock and roll to after takeoff.
After takeoff checklist. Landing gear.
Up,
Flaps.
0,
Fast reversers.
disarm,
Ignition.
off,
Pressurization.
effect,
PAX transition.
completed,
N1.
is an M1 climb,
APU generator.
off,
APU.
shut down,
Passenger signs.
and we'll keep them on for the time being,
CAS.
is clear.
After takeoff checklist complete.
Sweet. That's that all taken care. So I want you over to this display mode here. And it's accelerating to 270 here. And yeah, at this point, we'd just be doing our, I don't know, cracking open the champagne or something. 13,000. And a transition from takeoff to climb thrust on its own, or you just switch it manually like you demonstrated. Stu Flyer, normally you'd switch it manually. It will do it automatically once it runs out of takeoff performance data at about 15,000 feet, but normally you should switch it over yourself. APR arm, Winston, is your automatic performance reserve, so the engines are capable of pulling about an extra 5% of power if you should have an engine out, and automatically they will do that if you have if it detects an engine out, so it will automatically switch on once you are airborne for more than 5 minutes, or if the engines spool down below 79%, then it will automatically disarm itself. Yeah. I'll finally fly the Cathedral one properly. Did I? I called him, didn't I? Yeah, I did. Only 13,000 is what he gave me. Now, let's let it fly the thing. I don't care. It's not like I'm trying to get somewhere. I'm really mostly testing here, so... If it takes a little bit of extra time, I don't care. As long as we get to test the FMS. Maybe controller's watching. Oh yeah, we'd normally not fly the whole thing. Normally we'd get a direct right about here at Palm Springs. We tend not to shortcut you a lot out of... Really? I remember they usually would. Hey, Caddy Ray Buzz CG. Welcome aboard. APL use it for training. Well, in this case, we're just testing, really. So So we'll do the turn here momentarily. And yes, that arc just disappeared because of how the thing works. It just doesn't draw turn anticipation all that well. Terrible typing. Into the 7,000 generally shortcut out of 8,000. Yes, I know. Nightmare frame. Could have switched on my synthetic vision before. Whatever. It's not a rating flight I'm doing. I don't know. We can admire the crappiness of the standby instrument here. So this guy's simulated as its own AHRS, so its own attitude and, well, not a heading reference, it's just an AHRS, attitude reference system. It's got its own internal...
0 Charlie, contact Los Angeles Center. Yeah, 126.35, see ya.
2635, 0 Charlie Lima. Los Angeles Center, Challenger 650 Charlie Lima, 13000.
650 Charlie Lima, Los Angeles Center, climb tape level 230.
I'm in Tay 230, 650 Charlie Lima. Rock and roll. 230, so I'm just going to roll it up a little bit and we'll get the climb going like a so. As soon as we roll out here, I'm going to fill the seat belts and everything. Anyway, what I wanted to say here, you'll notice that right now this guy says 7.5 degrees nose up. We're actually more like 8.5 to 9. So that's because this guy is nowhere near as accurate as the inertial nav system as the IRS is. So you'll see it's kind of getting a little bit silly in terms of how far it is on pitch. As soon as we level off and, you know, sort of become a little real aircraft now. Ooh, fairly hot. Engines are working hard. ISO plus 17. Yeah, it's warm. So you'll notice there's a slight discrepancy. So this guy now says plus 5. It's more like 7.5 degrees. So plus or minus 3 degrees on the nose attitude, pretty normal. Because this guy has no notion of Coriolis corrections and some other corrections that the IRSs can do. Because he has no clue about positional error. So standard and standard. And this guy's also standard, so passing 19,000, that's all looking good, and 19,200, 300, all looking good. So, seat belts and no smoking off. So, you know, feel free to light them up, I guess. Gross. Private airplane, man. You can do whatever the hell you want. I gotta get another level off here. Oh man. Any upsets? So yes, a little bit, Winston. It does get a little bit upset. Not too badly though. Within, you know, plus or minus a few degrees.
Charlie Lima, contact Los Angeles Center on 133.2.
133.2, 650 Charlie Lima, see. Los Angeles Center, Challenger 650 Charlie Lima, flight level 230.
650 Charlie Lima, Los Angeles Center, climb tape level 400.
I'm in team 400, 650 Charlie Lima. Rock and roll, let's go. our final cruise altitude. Yeah, so currently this guy's a little bit low, a few degrees. He'll pull himself slowly up. So there's a self-writing algorithm in there that is looking at my various accelerations and gyrometers and everything. So I'm going to try and get close to real attitude. So currently you'll know we're effectively completely wings level, slightly above 5 degrees. This guy's saying we are like 2.5 degrees and slightly rolled to the left by about 2 degrees. At a BBJ on the certificate we allowed smoking on because the interior had all the special fabrics and stuff. It was only allowed in the office room, but it didn't stop people from smoking in other areas. Yeah, I mean, of course you can do whatever the hell you want, right? Especially if it's your own airplane. If people are bothered by it, you can always just leave the switch on. It's not like it makes that big of a difference. Are we actually going to even have any kind of cruise? I guess we are. Predicted top of cruise here is after apples. Yucca. Okeko. Berger. I think. Probably supposed to be some sort of a French name or something. Soggy apples. Gonna have some soggy apples. So, all the other lampy lamps here are okay. Actually, we don't need a logo light. Why the hell would we burn those bulbs? It's not like we're in daytime. It's not like it's going to make that big of a difference. .884 on the engine temps. Yeah, they're working hard. It's fairly hot outside. Plus 16, plus 15 on the ISO, which means turbine inlet temperature of 1278. ITT limit is 900, so that's the red line here. You can see 884 currently on the ITT, 1278 on the TIT, and the turbine inlet temperature. Glad you like it, Stanky Woo. I've got a lot of them. For instance, the Challenger doesn't have an APU door. The APU is essentially always, the APU inlet is always open, so always air flowing through the APU, even in flight. Which means, bring up the APU debug here, yeah, the APU is essentially freewheeling all the time in the air. In fact, it's freewheeling at like 2800 RPM. It's about 4% of its max RPMs. This is where it's just spinning about and doing nothing. Even though it's shut down. Almost no experience with X-Plane 11, but DCS, a little bit MSFS. Like aircraft, the military doesn't want to fly GE aircraft as well. MSF's not good right now, so you guys recommend XP11. That's not because X-Plane 11 requires a lot of scenery and add-on stuff. Should I spend money on it? Can I fly without downloading hundreds of gigabytes that I add on airports maps? Katie Ravas, I'm currently flying, this is stock X-Plane 11. It doesn't look very good. Admittedly, XP12 is going to look a lot better from what we've seen so far. And the APU will be clogged up by FOD. Bottle, I guess it could, but it's on the upper part of the fuselage. To get FOD up there, that would take a lot of trying. What's one more cruise out for the 650? I get a lot of challenges in the mid 400s. The Nightmare frame, this guy doesn't go to mid 400s. This guy goes up to flight level 410. That's our service ceiling. So Challenger 600s are going to be from typically flight level 350 up to 410, somewhere in there. We're not that high altitude for stuff. And to your question, yeah, when it's heavy, the Challenger is in like mid 30s. Yes, it depends on fuel, of course, and payload and everything, but typically. See, we started to turn way early here. We get the turn going. So there's up to 12 nautical miles how far early we're allowed to turn if we are above 350 knots true airspeed, which we are. And currently we're even limited to half bank mode. It automatically went to half bank at level 316. So that's why we're starting to that was way of an overshoot. Should have started the turn way earlier than this. Yeah, let's turn off half bank here to get on. I don't know, hang on, it doesn't even want that much of a bank here? Why did you overshoot by that much then, you idiot? That's weird. I think Global can help with default XB11. There's tons of freeway airports. Yes. What we've seen so far. You see more than we? Let's have the Challengers. Yeah. So the stuff that you might have seen in the mid 400s is stuff like the Challenger 300s. Those can go higher. They call me. Concerning XB12. Bottle, as you saw, it is possible to switch it over, but the FMS doesn't want to do full bank right now. It's not even requesting it. No idea why. It shouldn't have overshot by that much. I have to analyze that flight here. Entering some turbulence, I guess. Got any SIGMETs we need to check out? From Palm Springs, PSP to SJC. And no SIGMETs. Okay, well that kind of narrows it down. Everyone's gonna have to correct for getting bumped about a little bit there. You have login to be able to replay the AP values during that overshoot. No, I'd have to fly with some debug mode enabled stuff. How fast will you be able to get to 400? Push those engines to the limit. Don't worry, there you go. There's top of climb right there. It's predicting it in about 20 miles. We still got plenty of track miles left, about 150 miles at cruise, so not too bad. Cool. So yeah, at this point it's just monitoring and doing all that normal stuff that you would be used to. I just gotten a lot colder. Ice has also decreased, so having pressurization is good. So all the other stuff is looking cool. Since I'm flying fairly fast now, it's fairly slack in how quickly it corrects for the cross-track error here. But it'll get there. At high speeds, the correction algorithm is very relaxed. It's not trying to be very aggressive. There we go, 1,000 feet to go. Cancel the alert there. And as soon as it enters flight level, actually capture, this is going to jump up to Mach 0.80 for cruise speed. Be timed if you don't have a cabin call button. Fortunately, I don't know. Many of these biz jets, the pilots are the catering as well. Or rather, everybody just caters to themselves, right? Everybody just takes care of themselves, self-service, everything. There we go, VLS cap, and it's jumped up to Mach 0.80. But since we're up here, I'm going to go ahead and switch over to cruise thrust limit. These are going to go into little magenta donuts there. And it's going to decelerate the engines, bring it back to the cruise thrust limit. And be alt select. Let's see, approach, and we're going to be way out of the departure checklist portion here. Yeah, there we go, just there. That's our airplane just exiting the chart. Bye-bye. Damping bubble radius inversely proportional to cabin pressure. What's the atmospheric conditions around here? Ooh, 10% humidity. Yeah, it's fairly dry up here. But we're still not at the tropopause, which is at 55,000 feet, so it'd be like up here somewhere. Can't touch the ground speed acceleration on PE. Not yet, but we'll get there, don't worry. Sea level OATS 33.9 C here. Holy moly. It's hot. Our current temperature outside is minus 54. It's not that hot. Only isoplustery. You can see it's basically pulled in the cross-track error to nothing. If I bring it up into here, 0.05. So yeah, at this point I guess wing views and everything. Engines have also come back in thrust because we've reached our cruise speed here, Mach 0.80. Burning 850. We'll be arriving with 3,380 pounds of fuel, estimated currently. We can mess about with the perf system actually. I wanted to check if the integration has diverged between the FMSs. Perfect it. Oh, they're very close.
Delhi Center, good morning. Walker 385 level 310.
Just to back them
Walker
over.
3, Los Angeles Center, send me a cocktail 1 arrival, runway 26 left.
Just send me the cocktail 1, runway 26 left, Walker 3.
Computed cross tracker is 92.6 meters. And it's going to come down. Quit the AP work like a rat. Not really. It doesn't, it's not really optimized for that. I mean, I guess it theoretically could, but it's not really optimized to operate that way. Already an idea already how this handles in VR. I don't test much CVD systems with VR. It should work mostly fine. There we go, turn here. Yeah, I can relax the system even more by pushing turb here. It's going to go into an even softer steering mode. Now, that's not going to make turbulence go away. It's just going to mean that the airplane's going to be less concerned with trying to correct minor force deviations. And let's check my flight path over on Pilot Edge. So let's go to the live map. And this should be me. No, not that guy. Not that guy. Where am I? Am I here? Oh, there I am. You can see it over here now. It's overreading me by 1,200 feet. That is my geometric altitude, not my pressure altitude. So we're actually by 2,200 feet. We're 2,200 feet higher than flight level 400 in barometric. This would be geometric or geopotential. So, yeah. The Challenger has a rat anyhow. Yes, it does. Good flyer. It's called the air-driven generator. You can manually pull it out by pulling this lever here. I can't pull it out too far. It's going to deploy. And it also deploys automatically if the airplane's in flight and it loses all power. All AC power anyway. If I shut off both generators here at the same time, I'd get the ADG fall out automatically. In fact, it's once every 2 years, they do a test flight to make sure that the ADG can deploy. So yeah, and you can see now it's again corrected itself. Oh, it's a little bit off to the side, I guess, by 1 degree off, maybe 2 degrees to the left on roll. Pitch-wise, it's pretty much spot on.
Also 2 Romeo Bravo Vegas straight ground.
So yeah. Doing 448 over the ground here.
So 2 Romeo Bravo, Roger, runway 30 right taxi, Alpha Bravo.
Rear airspeed 463. No Mach mode on the ISI, correct? Yeah, no, there's no Mach mode for this. You can turn on ILS display if you had an ILS tuned in, which you don't have currently, but let's select an ILS that's nearby, something, anything. Well, let's see. Burbank, I think, should have an ILS. But we might be able to receive something there. 109.5. 109.5. If I tune you in now, it's not receiving a glide slope, but it does receive a localizer. It is receiving a localizer. And you got these are brightness buttons, and cage here recenters the thing back to center. So even though right now we are a little bit nose up, if I push cage here, it'll go back to 0 pitch, 0 roll, and from here on out it's going to essentially behave as if you had a mechanical attitude indicator. If you had caged it and then released it, then it's going to start tracking any attitude changes from that point forward. If I said like I'm happy with this kind of an attitude, it's going to recenter. And then it's slowly going to pull itself back up because I've got a slight nose up attitude. I'm going to do it very, very slowly, so it takes several minutes for it to actually show up. Slight turn. You'll see it won't even go to the full bank limit. It's just going to go a few degrees. You have a lib radio for audio ident already. Yes, I do, Winston. Honestly, I'm kind of scared for XB11 now. Abstinence.
What's up, 2 Romeo Bravo, Vegas for Tower, runway 30 right, clear for takeoff, right close traffic, report missile downwind shot.
I mean, yeah, it does look good. There is no denying that. It does definitely look like a pretty sim. Okay, stand by. Check some stuff. Opsinus, what are your observations there?
LA Santa Walker 380, we're leaving flight level 310. Roger.
Why is everybody so quiet? We're going to integrating ENU ECF velocity vector code in the SIVA. We enjoy my champagne and cigars. Reading the newspapers, I guess. Waiting for an engine to fail. Aha! You guys always just want a little bit.
2 Romeo Bravo, you're assigned to right traffic.
A little bit of extra,
Runway 30 right,
spice there
clear
for
for
the
the option,
burning
make right traffic.
CL650 PAS engine. What will happen, IRL, if in sim, if you were to override everything and keep the engines at total power for the whole time? Intel effect, you'd probably damage them. The engines are designed such that even if you shoved the throttles all the way forward, they're not going to damage themselves immediately. But you would be operating at what's called APR power. And so, if I bring it up over here, so the engines are nominally rated, so currently we're pulling on in about 6 kilonewtons of thrust. Static maximum thrust setting on these engines is 38.8 sea level static. They can go up to 41 kilonewtons for up to 5 minutes, if I remember right. And that's what the APR system, the automatic performance reserve, is for. Such that if you lose an engine on takeoff, it'll automatically push actually it won't even push anything. It'll automatically unlock a special system inside of the engine control here and effectively bump up the engine N1 setting, even without moving any of the thrust levers, by about 2% N1, and that's going to give you an extra about 5% of takeoff thrust. So it's basically designed to operate at that setting for a little bit. Now, once APR does trigger, it's not going to disengage, but as long as it's armed, it's going to disengage after 5 minutes after takeoff, or if you pull the power back below 79%. That is there to allow you to essentially get a little bit of extra boost. It's effectively what's called an overboost in Boeing terms, to give you 5% of extra thrust. What was so cool? Opsinus. Which planet except you were over the Pacific allowed to fly? And altitude and Hawaii. Please support click and drag as a way to make large changes on the rotary knobs, or it will be similar to the T-band where you really make small changes. I think the IXCG click and drag lets you swing large changes on heading bug and small scroll for extremely easy smart change option and faster than remote. Stu Flyers already does that, so if you're talking about knob acceleration, that's already there. So if I were to, you know, go by individual clicks, it's about this fast. The animation of the engine and trans. Oh yeah, options. That's going to be in there. Yeah. And so to get there is knob acceleration to implement it, Stu Flyer. So if I roll it a little bit faster, or if I'm rolling my mouse here, this is a lot faster than the amount of clicks that my mouse is generating. Yeah. In fact, if I go real fast, here you go. How quickly. Same thing on the altitude as well. Speed, we don't. Speed is always one click, one knob, because you don't generally make too many large changes. On speed, you're going to make like, I don't know, 20, 30.
Contact Las Vegas approach. 125.9er and the altimeter 3003.
03 125.9er, walk with radar.
Cool. Let's have a look at the ATIS there. Actually, what I can do is I can go ATIS arrival into SJC. And we can do auto reports. So,
Block 3 to Las Vegas approach, altimeter 3003, expect LS 22 left approach.
That is about half an hour ago. No wind, 9 miles, so it's a little bit misty. 21, 2997. Driving departing runways 30 left and right, visual approach, ILS 30 left approach in use. VFR departures, contact clearance delivery.
200 runway 30 right, clear land, wind, call.
Of course, heading altitude and flight conditions. Flight following, bus read back on runway. Advise information. Bravo, good stuff. These types of pages are also features the hostile TBM. Yep. And this thing's going to be study level, eh? Probably. Data link, yeah. All the pop-up pages will be in the final product. Yes, sir. Why would I remove them? I spend hours and hours making them. You can, if you want, you can spend hours and hours staring at them. Here's our data link status page, and just wait for it to populate. Currently, we are linked up to the BFL station here. Bedford or something. Flat terrain. Nothing interesting between there. Well, there's a lot of stations we can hear around here. 20 kilobits. We're running on VDL mode 2 on the SITA network. That's our VHF data link currently. We've also got 2 satellite data units.
0 Charlie Lima, contact Oakland Center 127.45. Have a good flight.
2745, 0 Charlie Lima. Take care. 2745. Oakland Center, Challenger 650 Charlie Lima, flight level 400.
Number 650 Charlie Lima, Oakland Center, descend via the Silicon 5 arrival. Report leaving flight level 400.
Descend via Silicon 5 and report leaving flight level 400. 650 Charlie Lima. So, got the arrival coded in Silicon 5. So that's all good. Rocks.
2242, verify squawk is 3575.
You're going to exterior view or not. Option is, the exterior view is a little bit rough, so
CL650 for some reason you're on NorCal departure frequency, Miss Tower.
Make it like this. On. Good stuff. Actually, let me uncover some lights here so it's a
JetBlue
little bit better. Stand by just for a sec.
Okay, good. You missed the stick waypoint as well on the departure procedure. Just as a heads up.
Okey-doke. Engine selection on the Challenger 600 really weird. I've anything like this before. It's basically a real airplane software.
Dallas 4782, contact Los Angeles Center 124.62. 124.62, Southwest 4782, good day. November 171, you park in North GA.
Good stuff. Here's our top of descent here.
November 99171.
We already got our top of descent. So here, check out cell. So we're less than a minute away from top of descent here. I'm gonna go ahead and roll this puppy down. First constraint is 260 here, so that's what I'm gonna set in. Gonna do a little bit of descent planning here.
Golf, Foxtrot, Echo.
So go into perf,
Cross runway 8 on
approach.
Foxtrot.
We said, let's go to AOC corporate. It's fetching a new ATIS for us, but it probably hasn't changed. So 21, 21, SJC. We don't know the runway yet, but we know that we're going to be landing at about 32.1 thousand. And VPath capture. And 650 Charlie Lima is leaving flight level 400.
Number 0 Charlie Lima, roger.
Okay, so 32.1. It doesn't know our runway yet. For time being, I'm gonna guess it's gonna be 30 left. It's gonna give us a set of speeds here. Should be a placard here for the pressures, but whatever. Thank you, Obstinus. Very kind of you. Okay, so we started our descent. It's also when you go in perf and you push VNAV setup here, it's going to always take you to the active phase. So currently we're in set phase 3, which is descent. It's going to target Mach 0.80 or 300 knots, whichever is lower. We know it's 2977 for Z pressure. I can actually even pre-select that. So if I roll this, I'm
Yeah,
just,
280 to set to maintain 3000.
I can pre-select my new pressure here, and it's going to be ready for me to just swap over. What happened to the Challenger 850? Why was that discontinued? So it's going to just stay the same since the CL604 engine. It's an older design, but it's cheap, absolutely bulletproof. There are thousands of them out there in service. Yes. So, in terms of the sense here, we can go ahead and bring up this guy, bring up this guy, and I'm currently tracking towards Trox here. For Maker's Trox, this is not to scale, so it's not showing the airplane position, but it will once we're out of that section there. It's between 320 and 260 at Trox, and so that is exactly what we're going to be crossing at. You can see that we've got 260 set and it's past that, so we're going to be above 260 at Trox. It's all good. I'll get to that. I'll get to your question, Optimus, about the Challenger 850, about what happened to it. Inexpensive operate since it's so old. And they're still being made, Optimus. So no, they're not obsolete. They have modernized the engine. They're the same rough design, but they have modernized and improved on it. So it's not like it's a piece of crap or something. Good. Tracking towards Trox, then Silicon, then Valley. We know that we'll be flying probably ILS 30 left. Yes, ILS 30 left. And in terms of parking, I'm just going to swap this over to the airport. Actually going to look where signature is, if there is a signature in SJC. Just going to do it quickly over here. FISDOME. I want to go to the FISDOME. I haven't broken any rules, I guess. Transient parking. Here's shelter.
Head 280, turn left, heading 160.
Control tower. Good question. We'll park here at the base of the tower. How about it? Is your constraints on the navigation display? Yes, you can. You go in here, displays, and altitudes. Honestly forgot about that. Yeah. There's a speed constraint, isn't there?
Roger.
Yeah, 280 at Trox, so it's slowing down here. Meet that constraint. I'm gonna get rid of that turb mode here. Actually, we can go all the way down on the selector here, down to 15,000. That's automatically going to take care of it. There's 15K. That's our minimum descent target. Anyway, yeah, you can show both speeds and altitudes. And ETS as well. I guess I could bring it up like that. 280, 20,000.
Yeah, 280, turn left, heading 130.
20,000. Good stuff. Let's do some checklists.
Descent checklist. Show the harness.
Adjust it.
Passenger signs.
Gonna bring up no smoking. Seatbelts are gonna go to auto.
Pressurization.
Is checked and set.
Fuel quantity and balance.
Is good.
280, miles from maintain 3,000 until established on the local line clear the ILS runway 10 at a pitch.
So FMS landing data is set. We can actually pre-compute our V-speeds. And all these settings here are looking good. I'm happy with the landing field length. We've got plenty of runway.
Approach briefing.
We don't know yet. Probably visual. Just to say 32,000, not probably 320, right? Alright, probably should say FL320B. I need to check that. Probably.
VNAV transition flight level.
That's something I still gotta implement. Fuel range of this aircraft. Optimus 4,000 miles is the still air max range.
Descent checklist complete. In range checklist next.
Good. Next one's in range. Is that a wind update that we suddenly jumped down on the speed there? Salesman range is 4,000, yeah. 4,000 is... You're going to be going very slow, and you can't have any wind. Well, not headwind anyway. And even there, it's just about barely doable. practically, if you don't want to go absolutely slow, more like 3,500 to 3,600 nautical miles. Salesman range, I love that. So pretty sure, pretty soon we're going to be coming out of here, out of that not to scale region. Wearing walking shoes and a swimsuit. It's barely any better than the 350. Well, hang on, the 350 salesman range is 33 or 3,400 miles. So lob off another 400 miles off of that. There's your actual range. And the selling point for 650 ain't exactly just the range. It's not just.
280 contact Monterey Tower 118.
It's not just the fact that it can go a little bit further. Are you actually gonna stop there? 20,000 or above? You shouldn't be. V out V cap. Why are you capturing here?
United 280 Monterey Tower runway 10 right, cleared to land to wind variable 6.
You shouldn't have captured there, dude. Last waypoint. Yes, I know. Unfortunately, I cannot go any further unless I know what my approach is going to be. Probably 3-0. So for the time being, just to keep the FMS happy. Now I'm going to do something that you'd never do in a lot of add-on aircraft. Was I'm going to punch in an approach. And we're going to transition from where? KSJC. San Jose. ILS 30 left. From Clyde. Probably. Valley to trucks. Not yet, thank you. Huh. Clyde, why didn't she sequence? Oh, right, I need to reselect you and trucks. And this way. Yeah. And we are just about to fall off, so I'm gonna grab Valley here. Go direct, enter.
Number 0 Charlie Lima, contact NorCal approach 121.3.
121.3, 0 Charlie Lima. 1213. Okie doke, so we've got Norcal approach, November 650 Charlie Lima, 15,400, and we've got information Bravo.
Number 650 Charlie Lima, NorCal approach, thanks for Bravo. Altimeter 299er7, expect ILS from 30 left approach.
Expect ILS 30 left, 650 Charlie Lima.
United 280,
So we are
right turn
clear to descend
on,
with the thing.
Right turn November, Alpha back into the terminal ramp, monitored ground 120.87.
November Alpha departing monitor ground, United 280.
Top of descent. Did I pass you already? Didn't have. Echo Pro OAT, so I'm going to get rid of you. I don't want TempCom today. And I want to look at my vertical deviation. There we go. It's just coming in range here. So we are clear to descend with the arrival. So down to 4,000 is our bottom of the arrival. We've got full foot wider cabin energy 4. Pretty narrow cabin. Always stepping over legs. As it comes to the approach, you plan for fuel prediction. Hi, by the way. Yeah, hi, June. Really late, but have you tried increasing ground speed? Biological nanobot, I'm gonna do it in a little bit. I'm currently flying online, so that'd be a no-go. There. So, 997, 13,800, 13,700. Yep, cross-checked. Makes a big difference. Cool. How are we looking on the constraints here? 250 at Wilson, something like that. So it's starting to decelerate. Here need to resize the car for a feel. Yeah, aircraft are small. Quite teeny tiny often, especially on long legs. Get surgery. Okay. So Wilson 8,000 or above, which we should meet no issues. Wilson 250 on the speed. Speed's bleeding back pretty good. Any new ATIS? What's the time? Just about. We're getting ready to get a new ATIS here. I'm just going to do a manual single fetch. Bill Bravo. Over an hour old. Okay, well then let's try and the auto update system should fetch a new ATIS when it is ready. FMS message. Loc will be tuned. Yeah, thank you very much. That's simply popping up that message because the left-hand nav radio I had manually set to something different. Right-hand it wasn't. So that one automatically will tune for me, but left one I didn't. The left one I have manually set to something different. So there it is. It's pre-tuned the localizers. Put on the ghost of the localizer there. How about that?
Challenger 0 Charlie Lima at Clyde cleared the ILS runway 30 left approach.
At Clyde cleared the ILS 30 left approach. Challenger 650 Charlie Lima. So at Clyde we are cleared. Just gonna go ahead and get the APU started. We are cleared for the approach, so gusty 4200, Clyde 4000 or above, got 4000 set there, still on profile. We could turn on synthetic vision here, get rid of the HUD if we wanted to. That also works. Let's become airline pilot pushing for an ATIS update because it doesn't want to wait for auto update. Yeah. Is that something you guys do as well? I can turn on landing lights, or rather, I'll just set it over to pulse. Set pulse. Huh? I gotta check why it's doing that. It should go to the middle position there. So APU is available. I'll turn on a timer here. In 2 minutes we'll switch over the packs. So now we're tracking the Clyde. Clyde Zulip Janes Hivac. This guy we can switch him over to the approach chart now. He's already ready for us to go. ILS straight in. Minima 257. So we'll get rid of this, and that. Bring that up. So arrow 257, 260. Mirror minimum set. And the approach goes from Clyde, 4000, Zulu, 3600, 3200, 2700, high vac, final approach fix, and glide slope intercept. Well, 4 levels of final approach fix. High vac's going to go with glide slope intercept. Okay, everything looking good there so far. The localizer is centering. I'm going to pull the speed back here to 210. We're going to continue the descent here. We are past Clyde 4000, so we can go down to 36. I'm also going to arm the approach mode. So this is armed automatic nav-to-nav transfer at this point. Actually going to roll it down all the way down to 2700, where we're going to get a glide slope intercept.
November 0 Charlie Lima, contact San Jose Tower 124.0, good day.
240, 0 Charlie Lima, good day. 124.0. And yes, that matches. San Jose Tower, November 650 Charlie Lima, ILS 30 left.
Number 650 Charlie Lima, San Jose Tower, runway 30 left, clear to land, wind calm.
30 left, clear land, 650 Charlie Lima. So we are clear to land. Let's bash out
In
the
range checklist.
There we go.
APU.
Is started.
Altimeters.
Are set and cross-checked.
Avionics.
Set.
External lights.
Are on.
N1 target.
Actually, N1 target. We're gonna switch you over to climb thrust. Start slowing down here.
APU PAX transition.
And this guy's rolling away from me. Doing the PAX transition here. A lot of work.
APU generator.
It's on.
CAS.
Checked.
In range checklist complete. Before landing checklist next.
I want to capture that glide slope already. There we go. Missed approach is climb 1900 and hold. So 1900 is the missed approach altitude here. Slow down to 160.
Before landing checklist. Landing gear lever.
Is down.
Nose steer.
Is on and armed.
Anti-skid. Passenger signs.
There we go. Passenger signs are set.
Wing cowl anti-ice.
Are required.
Continuous ignition.
And we gotta turn that guy on.
Thrust reversers.
Are gonna be armed.
Spoilers.
Are auto and stowed.
Flaps.
Are coming at 45.
CAS.
Checked.
Before landing checklist complete. After landing checklist next.
Cool. Start slowing her down.
1,000.
Gotta get that out here. Ooh, that was a lot of work. Okay, there we go. We're stabilized. This is VFR conditions, so by 500 feet normally you would have to be at least, but there we go. Let's sync you back up. Rock and roll. Before landing checklist is completed and everything is rocking and rolling. Good stuff. Just gonna get it stabilized on the approach from 500 feet. I'm gonna disconnect it by minimums just for funsies.
Approaching minimums. Minimums.
My airplane.
$100. 50, 40, 30, 20, 10.
Not too much of a pull. Right there. Charts are going to automatically then swap over to the airport. Gonna vacate left here. If I was a good pilot, I would have actually briefed where we're going to vacate.
Bird 0 Charlie Lima, left turn Juliet, all the way down to Victor, to the GA ramp, monitor ground point 7.
Left Juliet Victor and to the GA ramp 0.7 for 0 Charlie Lima. See ya. Alrighty. Just gonna stop here, get everything cleaned up. Those stow those guys disarm that and that. Get taxi recog lights on, anti-collision off. That and that. And all the other stuff is looking good there. Yeah, I'm happy with all of that.
After landing checklist. Landing pulse, recog lights,
Off,
anti-collision lights,
off,
continuous ignition,
off,
windshield heat,
and it's off,
probes,
off.
wing anti-ice,
It's not required, and off,
cowl anti-ice,
off,
spoilers,
load,
flaps,
up.
ATC, TCAS,
We would switch that guy over to altitude only.
radar mode.
And by
After landing checklist complete.
Juliet Victor
Engine shutdown checklist next.
to the end here. I'm gonna go to Victor. Over yonder. Man, you can really forget how to do this. This was quite drinking from the fire hose. Okay. Will we enter the GA parking area here? Or are we going to go to the base of the tower? Yeah, transient parking, yeah, sure, we'll go there. Text-to-speech personality, go to second high too. So to your question about text-to-speech, or your comment, I guess. This is auto-generated for a good reason. I could have recorded it. That's not the problem. The problem is I want these checklists to be user configurable, which means I cannot be pre-making samples for them, because then you have to redo all the sound samples anytime you wanted to swap the checklist out for something different. Checklists are fairly operator specific. Train an AI for your voice. Yeah, sure. With bespoke, yeah, that wouldn't be possible. So I've been thinking about integrating Google Voice or Google Text-to-Speech, but that thing costs a non-trivial amount of money and a bunch of integration work to get it working. And let's just park, I don't know, next to these hangars or something. Obviously, if you were actually flying, you'd know where to park. You'd have called ahead of time, organize everything with the FBO, so that would be that. But for the time, you know, I'm just gonna shove the airplane over here. Pull, brakes are on, so parking brake is pulled, and all the other stuff, gens are coming off.
Engine shutdown checklist. Taxi lights.
Are off.
Parking brake.
Set.
Reverse thrust.
Stowed.
Generators
Off.
Engine 2 shutdown.
Pull the engine. You get the boost pumps up here. Yes, they do come on, so that's a good check there.
Fuel boost pumps.
Off.
Fuel system.
Checked.
Engine 1 shutdown.
Good stuff.
Check ITT. Below 350 degrees Celsius.
Yep.
Anti-ice.
Is off.
14th stage.
We can kill.
Beacon.
Is coming off. Also the parking sign.
Nose steer.
All the signs there. Nosing steering is off.
ATC TCAS.
TCAS is going to be coming off. Just stand by.
Parking
we
brake
set
if
a
chocked.
code of 000. Parking brake. We had chocks in place, so we're going to go ahead and throw the chocks in. Push the parking brake back in.
Passenger signs.
Off.
Cabin differential.
0.
Engine shutdown checklist complete. Securing checklist next.
Yeah, so that is a full flight, and I gotta go to the bathroom. How about you folks? So, we'll just leave it here. Sorry about that. Might have been a little bit loud. There doesn't seem to be too much wind here at all. So all of that is out of the way. I switch you back over to magenta source needles so that we're in FMS nav here on both sides. And yeah, I'm gonna go to the bathroom and we'll see about what we can mess with next. I got a new ATIS. Well, that finally fired off. 15 minutes late. ATIS Charlie says issue 1753, but we are checking this every 5 minutes. So it might have taken that long for the damn thing to come out. Alt T, please. Yeah. More furious button pushing. Yeah, we'll mess about with some more stuff. I'll be back in 5 minutes. Gotta go to the bathroom, and we'll chat later. See you in 5. Welcome if you got 'em. Alrighty, so talking again about that text-to-speech stuff. So the reason why I didn't do it the way by pre-recording messages is so we can basically have you, you know, have all of this editable in the checklist, and therefore you would be able to, you know, make your own checklist if you want it. I've been thinking about making like a GUI app to let you edit this, but it's really not that hard to understand. If you know a little bit of XML, how to write it, and even people who've never seen XML, you know, I've basically given to CL650 Pilot about a 10-minute primer on what this is supposed to look like. He's a professional pilot, not a software engineer, and he's been able to pick this up and how to make a new checklist in about 10 minutes. So it's not that hard. You just, you know, copy line items out, and you can see that this is paired with that. So it's obviously some sort of a block from here to here, and this is just a single item. You can add attributes and stuff. It's not that hard, and just rewrite stuff the way you want it. And there you go. That's all you need to do. So that's why I didn't want to make them pre-recorded. In terms of what the actual, yeah, I mean, you're not a software engineer, so it's understandable you wouldn't know about it because that is not your job. It's fine. I mean, we all specialize in something. So let me just do a little bit of a debug is equal to 1 and make J16. Actually, nice, make J16. And so I'm just pulling in the change that Gordon has pushed so we can hopefully get some fixed up cockpit visuals. I'm gonna disconnect from Pilot Edge. And fingers crossed, if I reload now, I should still get essentially the same state of the aircraft. And I forgot that I gotta reload with visuals as well. Crap. Stand by. I'm gonna have to do one more reload. Yep. So state remain because I switched over to a production build. I got to do the reload with aircraft and art. Just landing gear lever. I'm sorry, Dave. I'm afraid I can't do that. Yeah, so in terms of text-to-speech, on Windows and on Linux, we use, on Windows and on Mac, we use the OS provided text-to-speech system. So it's going to sound different to what you just heard here, because this, the way it's read here, is using a different TTS mechanism. Linux doesn't have, X-Plane doesn't have a native text-to-speech functionality, but there's a number of open source text-to-speech engines in Linux, and the one I'm using is called Festival, or the one I've integrated is called Festival. It's an open source project. On Linux, it's about as complicated as doing, you know, apt install Festival TTS or whatever the name is, and that's it. You're gonna get it, and it's automatically going to pick it up from the command line, because the only thing really that we do is I just do this TTS, I think, something like this.
Hello world.
This is effectively what the aircraft right now is doing. It's just piping a bunch of text to be read into the Festival command, and that's it. So it's not at all complicated. On Linux, and on Windows and a Mac, it's going to sound a little bit different depending on what sort of voice and setup and text-to-speech setup you've got on that specific operating system. Right, and if you want to do another flight, you don't have, right now the system is going to think that you're going to go to the shutdown checklist and everything, and the securing checklists, but no, you don't have to do that, because we are still, we still want to do, we want to do another flight. So I've put in, there are commands to control the entire checklist system. The auto checklister is what I call it. Basically, it's like a first officer reading off the checklist for you. I've put in key commands for you to control everything. Normally, I have this bound to control space to just check off and confirm one of the items. but there's also a menu up here that lets you invoke any of the commands from the menu. And if you want to do a full flight again, you just go restart all checklists, and it'll restart all the checklists from the top, as if you were doing a new flight. Will that work on Windows if you have a different language than English on your OS? Will it still be able to speak English? Future Pilot Suite, I think it should still speak English, yes. Can you show us the aft equipment bay, or is that thing not ready yet? It's not fully there. I think Goran's got some of it already in place. Sorry for the noise, but it looks about like that. There's gonna be some more crap in here, but... let's see, what did I want to do here? There was another thing I wanted. You're probably refuel. I'm gonna call the fueler guy. Hey, fueler guy. How are you doing? And we're gonna, I don't know, get an extra 1,000 gallons on board. Just to make sure that we've got something on board to work with. Although we don't quite need, we're gonna get 1,000 gallons. Sure, why not? We can carry that much fuel, no issues, and that'll be that. Enter. So we've got a preset established here. We're gonna bring up the interior refuel defuel panel, and I'm just gonna go ahead and start the pump. See, I forgot to switch off the refuel defuel panel. I'm gonna open them all up and do a shut off test. That's all working good, so we're going to close these guys now again, and we're just going to refuel the mains. If there's any fuel left over that can't go into the mains, probably isn't going to be, we're going to shove that into the tail and the aux. I'm just going to get rid of that for now. Let's see. It's been 24 minutes since we landed. And the flight took 1 hour and 6 minutes. And you might have noticed as well that this FMS here aren't just showing anything. ETIS. Huh, right, yeah, I didn't reserve. Anyway. Alright, we're off pilot edge anyway, so who gives a crap what that's going to say now. You'll notice this FMS here, because it was showing a flight plan page or an FMS page, automatically went to the flight log, and this automatically comes up after you land. You can disable that if you don't want it. That is the default behavior, but you can disable that. In defaults, it's like on page 3, there we go, flight log on landing. So if you don't have that enabled, then this is not going to come up. And normally this 1 minute or 30 seconds or something after you land, this is going to automatically come up on all FMSs that have any kind of FMS page display, FMC page displayed. Where are you going to fly this time? Assume you're doing another flight now because you're refueling the plane. The bottle, I'm going to do a little bit of testy test, so I'm not actually going to fly anywhere. We're just going to go and take off here and do that. People wanted to see what happens if you do ground speed acceleration on the airplane, so I'm going to show you what happens. Anyway, and also, by the way, another, I guess, somewhat reasonably important detail. We are off pilot edge, right? Yes, we are. Good stuff. And so you'll notice that flight log here. What if I want to get to my flight logs? Not a problem. Go into X-Plane, output CL650, and it's under Avionics and VRAM, and you've got a bunch of CSV files. And so these CSV files actually contain all the memorized flights that you've done on the aircraft. Everything that the thing has when you've flown. It actually gives you a little bit more data about stuff. It'll give you, your position, where you took off from, and so on and so forth. So this is today's flight. Palm Springs, San Jose, liftoff or takeoff point, landing point, and fuel used, landing time, air distance, ground distance, blah 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 blah. if you intentionally entered a waypoint in a different departure airport, it had by SID from there. Different departure airport. I mean, what would happen is you would be nowhere near the flight plan, so it wouldn't even engage LNAV. LNAV would stay armed, but your needle here would never center. It would forever be somewhere, I don't know where. It'd be way off path. It would be no different if you had, if you were taking off from the correct point. For example, if you fly departure from SFO while at SJC. It would never center the needle, and therefore LNAV would never capture. Oh, nice and cool already. Half an hour later. Fly departure, yeah, okay. Still fairly toasty here. If you were to look inside of the aircraft, inside of the engine, it would still probably be a little bit of heat shimmer there. Yeah. Cool. I'm just gonna shut off. I gotta implement this, the windshield heat system. How are we looking on that refuel, mister? Almost there. Interior refuel. Defuel panel. So left tank has reached full. Now let's just open up a little bit more. Probably just jostle about the system, couldn't quite decide. Okay, so both tanks are now completely full, 98.5, 99% full. Still got 50 gallons we can take on, so we're gonna put those into the center and tail. Or they call it aux and tail, but really it's the center and tail. Well, not center, because there's a center tank, then there's a forward aux and an aft aux. So these guys are full, close those. How much we owe? $5,600. Coming up to $5,700 by the time we're probably, they're just about done. There we go. So refuel, defuel complete. Total bill $5,677.95. Cool. So I'll leave that tab for up to somebody else. I'm gonna start a new flight plan here. So go to San Jose SJC to SJC, just to have something in there. V-speeds deselected. Yes, thank you. Don't care. Temp comp we're gonna disable. We're not gonna fly temperature compensation today. No flight plan. Yes, I know. Because there's no legs currently entered in there. And what did I want to do next? Disable terrain over there. It's not necessary. Let's see. What else did I want to do here? Alrighty, let's start messing with the airplane. So we've got everything pretty much set up. So what I'm going to do here, I'm just going to go and turn on these guys. And I'm going to reset all the checklists. So restart all checklists.
Flight compartment checklist.
We're not going to do flight
AC and DC electrics.
do the flight compartment checklist here. And normally you would, but whatever. Just going to go to the next one.
Engine start checklist. Doors.
Cool. And by the way, notice it still says we only got 10 pounds in the center there, even though the actual, so this is what I'm talking about. Don't consider these, oh, it's not reading 0 in the center. Don't consider these to be gospel, because you'll notice if I bring up here fuel state, fuel system, we've actually got in the center aux tank, we've got 360 pounds. The tail is fairly empty. There's like 20 pounds there, 20 pounds there, nothing. And the actual tail saddle's got about 60 pounds between them. Center aux tank has about 360 pounds in it. The rest are pretty much empty. But we got an extra maybe 400 pounds in the center and aux tanks, and they're not showing up anywhere. They're reading 0 because it's such a small amount that the indication system, the fuel quantity indicating system, is just nothing. It's not reading anything there. And all my switches are in the correct position. Lovely stuff. CB panel lighting. All this is looking good. Lovely. For those who don't know about this, this horrible sound set you can generate is if you start both DCU oral tests at the same time. Cool. So, yeah, these, we got the beacon on, we'll arm B ignition for this time. Let's go continue with that. So doors are closed.
Parking brake and pressure.
Actually, parking brake. And pressure is over here. Hydraulics 3000, good. And we'll get the chocks away.
Fuel quantity and balance.
Hey Jay Kraus, jet pipe overheat. I'm gonna hear jet pipe overheat. Let's start. Just both of them for extra memes.
Jet pipe overheat. Jet pipe overheat. Overheat. Smoke overheat. Bleed smoke. Air duct. Bleed air. Anti-ice duct. Anti-ice overheat. Wing overheat. Config flaps. Trim. Config spoilers. Config spoilers. Config autopilot. Cabin autopilot. Door. Cabin pressure. Nose door. Nose debris. Engine oil.
Anyway, it's kind of like row your boat. Good. That's not what I wanted to push here. I'm gonna get rid of you. Okay, so fuel quantity and balance is good. Balance is good.
Beacon.
It's on.
Fuel boost pumps.
On.
Ignition.
Be armed.
Engine to start.
Okay, rock and roll. Let's go. Good, wave until less than 120 ITT. There we go. There's not going to be that whoosh sound anymore on a warm start. That low frequency groan. Okay, and there's another one. You would start your chrono. I think there's a 1 minute duty cycle on the starter. Duty limit on the starter. Come on, here we go. For 90 seconds, ah, cool. Even better. We'll get Z-Gens on. All the other crap here is looking good. Those guys can come on, and everything else I'm happy with. Stuff, and we'll just throw in some sort of a code here. We're offline, so who cares? Did I turn off TCAS again? There we go. Check that we were definitely not on pilot edge. We're not. Good stuff, so we're not going to annoy anybody.
Fuel system.
Is checked.
Engine 1 power.
Started.
Engines. After start checklist. Generator 1 and 2.
Checked.
Ignition.
Disarmed.
Packs.
On.
14th stage.
Open.
Cowl anti-ice.
Skip that.
Flight controls.
Flight controls. You check. Sure. Get your little flight control check out of the way. And Denry, thanks for the follow. Welcome aboard.
Ground spoilers.
Or auto and stowed.
Flight spoilers.
Stowed.
Cowl anti-ice.
Dream is real gold mine. You want to, oh, thanks, Medley Pilot. I'm glad you're liking it. What about COM3 and HF radios? HF12 radios. COM3 is in data mode, and HF currently tuned to whatever.
Supplemental ground wing anti-ice.
There's our first
Fuel
flight of the
balance.
day. Is checked. Looking good still. Balanced.
Trims.
Trims. I didn't actually reset those. Oh, they're pretty close. And they're still on, so all is good.
Nose steer.
Yes. Armed. I was asking about Tune 2. Okay. What's on page Tune 2? Okay, well, there you go. Your transponder code ID, HF control, and COM3 control. And also your HF stuff here.
APR.
APR is armed.
ADG unit.
Test is, that'll be only first flight. We tested again. Okay. It would not light up all of them, only one of them.
Supplemental ground.
So we'll skip all of those.
ATS.
ATS. Yes, ATS for you. What you need is an OAT entered in here. I think there was like 21 or something degrees. And go like so that we got takeoff thrust set.
ATCT CAS.
Altitude on.
After start checklist complete. Taxi checklist next.
Yeah. Bottle, yes you can. What's the audio starter? I've heard my X-Plane installed duty. It is usually on the ground. Well, in my case, it's probably because I'm doing the text-to-speech stuff, which shouldn't really stutter, but it might be a Linux artifact. Well, in sim currently, unfortunately, nothing. You can't. None of the simulators actually simulate anything with respect to HF radios, or rather, none of the networks do. I've got the whole thing here, like change power settings, change squelch, change tuning modes. So all of that is here, but what we need is capability to use HF radios when we follow HS650 aircraft. What does test do? Bottle Rocketeer test, it just does a 20-second test internally on the radio. That is just a sort of normal sort of test you could do if you were suspecting some kind of problem with the thing. After 20 seconds or so, it will just go away. No fancy sounds, no. Unfortunately, nothing here. HF radios, we were asking way too much of this damn thing. Hey, parking brake off. We'll take it a Golf and then hook a right there, hook a left. First get on Golf here. You should add Oakland Oceanic. I've been trying to convince Keith to do it, but I can imagine that he wouldn't want to waste time on that. You speak about supplemental ground wind anti-ice system. Captain Crash, are you genuinely asking because you don't know, or are you asking because you want me to talk for a lot of time? I have no idea. Yeah, okay, so CRJ didn't have it. Okay, let's park it over here. We're gonna switch to non-real weather for a second. We're gonna make it freezing so you can see what it does. Parking brake out. Lighty light on. Cool. So I'm gonna make it fairly cold. I'm gonna take it over to custom weather. I'm gonna make it like -12 or something. At this point, check test procedure for is fairly involved too. Yes, it is. Well, it's not involved. It's more like it's dumb. It's yeah. So supplemental ground wing anti-ice was added. I think it was in the CL605 and later. If I understand it right, it was primarily created because of one specific crash. It was a CL604, I think, in Birmingham, which crashed on the ground. We just de-iced, and then no earlier than 2 minutes prior to takeoff, we turned on the wing anti-ice. Yeah, so, and I think it was because of a crash in Birmingham or somewhere there. The Challenger has a very highly supercritical wing, which means it is extremely susceptible to frost buildup, especially on the leading edge on upper surfaces. So, what has been figured out is a lot of crews delayed wing anti-ice activation, or they thought they only had mild frost on the wings. They didn't really consider de-icing to be an issue, and they delayed anti-ice for wing anti-ice activation. They forgot about it and stuff like that. So what Bombardier designed is sometimes they call it low temperature ground wind anti-ice system, LTG waste, instead of supplemental ground wind anti-ice, which kind of betrays a little bit more what it's about. So what it does is if you have, I'm going to bring up here engines bleed 14th stage. So we got the 14th stage open. If I am on the ground and I turn on cowl anti-ice here, you'll notice that it also opens up the wing anti-ice system. Now what the hell happened here? Still got the wing system set to off. This horse should knee-jerk reaction to one incident where pilot screwed up not following the AFM. Yeah, yeah, that's a gentle way of putting it. Yeah. So the idea was, or the idea of that system is that whenever you've got cowl anti-ice selected on the ground, it also opens up the wing anti-ice as well. And there's a low temperature trigger threshold now reset inside of all the rules in the AFM. The altitude rise is not necessary at all. Yes. But it also doesn't hurt to have it. There's supposed to be a button here. Oh, whatever. Button fell off. Whatever. So whenever you've got the interesting feelings about that you've got there, CL650 pilot. So whenever you've got the cowl anti-ice turned on the ground, what it does is there's a bunch of relays and a bunch of wiring which I had to reproduce, which is an absolute nightmare because it's all electromechanical. It's not done in software. So there's a bunch of electromechanical relays and all that kind of good stuff that it's reproducing. But basically, when these guys are selected to on, it also opens up the wing anti-ice system, and consequently, you've got a fairly hefty temperature increase on the ITT here, just because of the fact that we're stealing a truckload of air. I'll post the URL to the incident. Yep, sure, cool. You should be able to post it in here as well if somebody wants to know. So there's a lot of heat increase on the engines just because of the fact that we're stealing so much bleed air out of them, and so we're heating up the wings as well as the as well as the engine cowls. Now, the system is designed in such a way that it'll shut off at about 28 degrees, and it'll cycle between 21 and 28 degrees. So the wing will be kept low temperature, but not frozen. It's basically just trying to keep it just above freezing point to prevent it from frosting up and covering up with any kind of ice. It's not so hot. If you had, you know, your full-on wing anti-ice turned on, this guy could get easily very, very toasty, you know, 50, 60 degrees Celsius. First time a pilot lands gear up in the Challenger, Bombardier will bend to transport Canada's wishes again and install an automatic landing gear down system. Maybe. Anyway, so getting back on track. If you had this on, this would go up to, I keep forgetting, it's like 80 degrees or something on the wing. The problem is that is way, way, way too hot. Yeah, bake the fluid onto the wings. Right, so the supplemental ground wing anti-ice is meant for the cases where you will de-ice. Probably you're going to de-ice. But the wing's going to get a little bit warm, but it's not going to get so hot that it actually would bake on the wing, the de-icing fluid. And at the same time, one of the problems with wing anti-ice, as soon as you select it off, either standby or on, that gives you a huge takeoff performance penalty. You'd have to basically at that point have, first of all, you cannot take off both packs on engines and wing anti-ice on. That is not allowed. And second of all, there's a lot of performance penalty associated with wing anti-ice. So the supplemental system here is triggered. It is also wired up such that if you basically put the thrust levers beyond a fairly low detent, like I don't know, like 10 degrees away from full idle, so it basically will let you taxi with the thing, but it's not gonna, it's automatically gonna shut itself off as soon as you put the thrust levers. So I've got the thrust levers here, right? So it's gonna come on, and as soon as I put the thrust levers forward, you'll see it immediately kills the supplemental ground wing anti-ice valves. And sorry for the textures here, it's just that X-Plane kind of losing its mind here because of extra allocation issues and all that fun stuff. Anyway, errors have had that for decades. So the idea is that whenever you're taxiing around on the ground with the wing anti-ice turned on, it's automatically going to de-ice the wings for you without you having to worry about overheating the wing. I get to choose if they want to get the wings warm. Yes. They didn't follow the rules, so now they don't get to choose. So the wings are going to be a little bit warm, but they're not going to be overly warm. So if I just let it sit here, you'll notice that it's going to start cycling. So just going to let it sit, let it sit. You can actually taxi. So brakes are coming off. And make a turn here. And you'll see once the wings here get to about 28 degrees, more or less. The temperature switch has a little bit of fuzziness in it, so it's not always going to trip at the same point. But once these two wing temperature lines here get to about 28, 29 degrees, thereabouts, it's going to shut off the wing anti-ice valves on the respective side. I think I can take this taxiway all the way down to the end. Can I? Almost. I'll take it a little bit. I'll take it away. A bit of ways. See? Now it's just shut off the left side here. You'll also notice this on the ITT here. Suddenly the left engine's ITT has gone down. And you'll notice it starts cooling off. And the right side's closed. Right side's gonna start cooling off. Once it hits again about 21 degrees, so there's about a 10-degree hysteresis, it's gonna open up the valve again. Did I take a left here? No, not yet. Oh, that's some sort of a weird thing. There shouldn't be a taxiway here. Whatever. And the test button, is that just checking the temperature? It's even dumber than that. It's just checking one time delay relay, nothing more. That's all it is checking. And it's literally just waiting for 2 minutes to pass, pretty much. There we go. Right side's open, left side's open, and it's warming up again. Maybe 5-degree hysteresis or something like that. Will we get the handbook with this craft? Probably not. That'll be a very big handbook. Gonna take a left here. AD mandatory install for all Challengers, just new Challengers. I think CL650s and later have it. Remember the checklist was Cal, anti-ice, then supplemental ground, yes. So you need both on, otherwise the test doesn't work. Reflected reality sim. And Jesperly Groot Officiel. Thanks for the follow, welcome aboard. So you can see it's cycling here. Now it's heating from the right and not from the left. So it's kind of cycling on its own. Each side is treated in an isolated manner, so there you go. I think if we open up the isolation valve here, it's going to close, wouldn't it? Oh, they are going to cycle both of them. Thank you, thank you. Now they're both heating up. Right side's probably gonna close first because it's a lot warmer, by about 3 degrees. Yeah, these are the sort of temperatures this thing keeps. It'll be warm to the touch for you to touch it, the wings, but they're not gonna, you know, you're not gonna burn your hand or anything. I spoke with the engineer who designed it, you know, and asked why, since it's just checking 2-minute timer, it's in the after start checklist and would sit on the ramp with engines running, wasting time. That they hadn't thought of that. Okay, lovely stuff. Here we go. Right side's closed. Left side's closed. You'll see they triggered, each of them closed at a different temperature. That just happens. Sometimes they close a little bit at different intervals from each other. They're not, you know, following. It's not, I'm trying to simulate this to not be like a computer where the exact number is just absolutely an endpoint. So there's a little bit of fuzziness because these are analog switches and sensors and all that good stuff. And yeah, as for, no, I see no human field of endeavor is protected from random stupid design. Yeah. As for exactly what happens during the tests, I can show you exactly where it is, what it does. Stand by just 1 sec. It's section 30, ice protection, and it's in the wing anti-ice control and indicating system. So let's hop over here. Where are you? Wing anti-ice. No, not this one. Maybe. Hang on. Ah, there we go. So this is the low temperature ground wing anti-ice system. This is the wiring for it. You can continue with the other checks or just sit there waiting. I suppose. So which one's, there we go. Time delay test low relay. So this is the test switch. Well, pretty much. It's a relay really. It's time delay. It's a time delay relay. But really, what you're checking is here with this. You're basically closing a bunch of these lines and just checking that I think one of these guys comes on. I'd have to check the exact code to be sure. But you're basically just checking that one of these relays goes through a time delay, and that's it. Left test low, right test low relay. One of these guys just closes through a time delay relay. And again, I had to code all of this. Damn, I can tell you, mapping out this horrible mess of wiring was not great fun. But it's there. And it does what it's supposed to. So you're supposed to push the test here. No, actually, no, you're supposed to go like so. Off. On. Wait for the lights to come on. Good stuff. Start a timer. Push the test. And within 2 minutes, we should get a test okay here. And so we're just waiting here. Waiting. You can do some checklists, I guess.
Taxi checklist. Taxi lights.
Yeah, sure, on.
Wing and cowl anti-ice.
Testing.
Brakes and steering.
Checked.
Reverse thrust.
Is armed. Got the lights.
If taxiing to the ice.
Not.
Lamps.
Are set 20.
Altimeters.
2997. 2997. 2997. Set 3
Radar
times.
weather.
Not simulator currently.
Takeoff briefing.
Takeoff briefing is completed. Whatever, we're just gonna go.
Taxi checklist complete. Before takeoff checklist next.
It's gonna fail the test if I remember right. Bottle. You're gonna get a fail low or fail high. One of these lamps is gonna come on. So again, just waiting for 2 minutes. That's all you do. And within 2 minutes, we should get a test okay here. And you don't even have to have the engines running, if I remember right, for this. Come on. There we go. Test okay. There. That was the low temperature ground wing anti-ice system. Kicking hornet's nest. Ask a bunch of Challenger pilots what they think of the supplemental ground wing anti-ice system. Yeah, I think we've already determined that there's a lot of choice words about that one. Anyway, I'm going to switch it back over to real weather. So wing anti-ice is going to come off. Or ground or cow anti-ice. Because it's 23 degrees out there. So that is definitely not required anymore. Good stuff. So let's go. Engines are heating up now because they're starting to ingest warmer air. Cool. So probes are coming on. Lighty lights are coming on. These lights are coming on. Rock and roll.
Before takeoff checklist. Passenger signs
are on.
Anti-collision lights.
They are on.
Probes
on.
Windshield heat.
Did I turn off the parking brake here? Come on. It's a problem when you're using a button for brakes.
Wing and cowl anti-ice.
Not required.
Continuous ignition. ATC TCAS.
ATC TCAS would go to TARA.
Supplemental ground wing anti-ice panel.
Is switched on.
CAS takeoff config OK.
Is shown.
Land impulse record
Set.
Before takeoff checklist complete. After takeoff checklist next.
Takeoff. We run in the background when the tests switch off because Toto turned on the test. Yes. Is essentially always in test, I guess, if you want to look at it that way. I should have put in how much fuel we actually got on board with the stuff. Now, as funsies, we can go to perf and add here. I'm gonna sync up the fuel state from the tanks, because I'm lazy. For funsies, I'm going to show you how much the fuel quantity with the same takeoff pronunciation, yeah. You need to have checklist running your own voice instead of this weird TTS robot voice. Yeah. I'm going to show you how much the fuel value fluctuates during takeoff. So watch this. So currently it's reading 9,090, 9,100 pounds. So brakes are coming off. And so turn on the ATS. For 91.1. There's go V1 rotate, yeah, sure. Positive rate. So, 200 pounds, 300 pounds nearly. You show off that feature that where the ATS disconnects when you slam the throttles down for an RTO. Sorry, I just did the takeoff there, just normal. So, perf, climb. So that is why you don't put too much stock in these fuel measurements. Transition the packs over. Feel good on pressurization, so a poo is coming off. There's 1,000 feet to go. Sync up into heading mode. You see, as we level off here, climbing back up. We might have burned maybe 100 pounds during that takeoff, but not, you know, an insanely large amount. In fact, I can tell you most likely the FMS has a much more accurate idea of how much we burned. A fair amount. Actually burned more than I thought. 8750. This is now overeating by 200 pounds, give or take. Yeah, it's gonna start coming down. Maybe the original estimate was wrong. That's the thing with fuel. You're never sure who lies more. Usually it's these guys that are lying more. But stuff happens. Actually, now that the fuel's finally sloshed back close to the probes in the center, it's finally indicating 200 pounds. We had like 300 in there, or maybe 400, I don't know. Now it's indicating 220 in the center. How much we actually got in there, let's see. We actually got in that 365 in the center aux tank, and the saddles are emptying here pretty good. Yeah, it's finishing up transfer from the tails forward. And I should be just about getting ready to shut off here. Pump is pumping, pumping. And 2 pounds left. Actually, tail's got 16 pounds in it, so that's going to take a while to empty out. We got a little bit nose up, so the fuel in here in the saddles flowed back into the tail here. No, it's just stopped the transfer, probably just got uncovered. Really hard to know when this thing is just about barely 14 pounds of fuel might be like lost in cracks and everywhere. But yeah, so 370 in the aux center, indicating 240. Now it says 9,000 total. Fuel totalizer says 8650. Who knows who's lying? Actually, this is now probably a little bit more accurate because of the fact that we've previously synced it up when we were slightly nose down on takeoff or before takeoff, and so this quantity didn't account for what we had in the center and tail. And another one of those moments. Good. So we wanted to mess about with that time acceleration stuff. Let's come up a little bit higher, up to 12,000. Let's go. piece of geometry floating that has a nose, some sort of antenna. No, it's just a piece of geometry that Gordon hasn't removed yet. That stuff here, that's just something that's gonna get removed. Sounds like a Challenger. You'd hope. So come to 270. You'll notice that it steers very, very gently. It's not trying to immediately slam to 270 where it's just going to level off and then reaccelerate. So the autopilot has a fair amount of softness built into it. So disarm that. That's essentially the after takeoff checklist complete. I'm not going to bother with it. So there's Jepson Navigraph integration. Yes, there is. That's what this is. Cool. So let's start out gently with the abuse of the systems here. There should be a thicker line here. This is something I gotta fix. And Muse is on Twitch. Thanks for following. Welcome aboard. Thank you. Welcome aboard. What is Gordon working on? Is he existent at all? Yes, he is. Don't worry. Yes, he is. Good. So I don't need that. Hang on. Let me take some notes here. I forget all about these issues that I found. Not that. I'll grab you. So. How was it that I wanted to take a note of? Crap, see, barely between me pulling up a text editor, I forgot what I wanted to take a note of. What was this thing that was just broken? It was just on my mind. Correct. Anybody remember what I was talking about? Line on this. Right now, yeah, it needs a thicker line here. Light. Okay, so FLT synoptic page isn't using the correct line thickness. Thank you. I do have a document for this. Which I don't know where it is. Yes. So these should be a little bit thicker. These are way too thin lines. These should be about that kind of a thickness right there. Good stuff. So put our little thinking hats. Right. You wanted to see what happens to the airplane, how pissed off it gets if we do. So first of all, time acceleration, not an issue. I can push time accel just fine. Thanks for follow, Desmond123. Welcome aboard. So I can push time acceleration just fine. Now it is a little bit limited in that if I don't get enough frame rate, obviously, then it's gonna be limited. But you can get up to 3x easily if you got 60 FPS in the simulator. More than that, you're gonna have to have a higher frame rate or disable VSync or something that lets X-Plane accelerate up above 60 FPS. Basically, X-Plane always tries and maintains 20 FPS in simulator time, so there's at least 20 simulation steps per second. What's the time speed acceleration? It's broken too? No, time acceleration works. And if you're flying in real time, it's going to be a little bit weird because your clock is going to be not really behaving right, but generally that one's safe to use. Ground speed acceleration, let's have a look, just for funsies. I'm going to make it mild. We'll bring up GPS Unit 1 debug. And watch over here is our ground speed. According to GPS Unit 1, just still got to fix it. It's a little bit too unstable. Ground speed is here, true airspeed, everything. good stuff. And we're also going to bring up INS IRU State 1. So, let's see, turn on ground speed. So let's start out mild. Actually, I'm going to bring you over into that kind of a format. Yeah, sure, whatever. Actually, I'm going to program in some sort of an approach. Yeah, whatever. Golf, three-stroke, I don't care. Something so I can get something displayed on here in terms of flight plan. System's mostly done. Yeah, pretty much. Suit flyer mostly done. So if I time accelerate through the turn here, you'll see everything works fine. Airplane flies just fine. It flies faster, just because more time is passing, but everything is consistent. This is your alignment error. So the stuff after the slash here, that is the error in attitude and roll in pitch of the INS from truth, right? Those are still okay. 0.005 degrees misalignment, not an issue. These down here are not important, they're for something different. These are really what we care about. Watch what happens if I just go to two times ground acceleration. There we go, 2x. GPS thinks that we're flying 660 knots now. So ground speed has picked up a lot. This guy's kind of still sitting here in alignment, so that's all good. He thinks we're doing 600 knots. Okay, cool. So actually it has picked up the acceleration. So this guy hasn't desynchronized. If I go to 4 times ground speed acceleration, this guy's going to drop out of alignment. Because we're going to go... So we've lost alignment here because this guy's seen that we're going over 1,000 knots, which for him is an error. And if I go to full 16x ground speed acceleration, we're going 3,000 knots, according to the GPS. Autopilot's having trouble maintaining attitude. So, and if we go and restore it back, now we've stopped and probably starting to go backwards on the GPS unit. What's the FMC position status? Here's ground speed acceleration. 8x. FMS is just left in the dust somewhere. It doesn't know where we are. I've restored it back. Okay, GPS is trying to require. It's caught itself, but INS alignment has been dumped, and the autopilot can't fly that either. It's just too. It's basically doing something really crazy. Heading mode is gone. Can't engage it anymore. I only get roll mode. Also, the IMUs, the inertial reference units, have gone into reversionary mode. Now I can get them back a little bit. So if I go index, IRS control, if I go up and where's my magnetic compass? Oren, you removed my magnetic compass here. That's an important piece of equipment. Well, okay, I guess I'll just have to read my heading off of the map here. 122. So enter 122, go into set heading. Now we're in full reversion mode. Now we are going to get heading hold. We should at least. Oh, why aren't you giving me heading mode? Well, anyway, I'm going to go to FD sync here manually. I'm just going to turn around. Just went to control wheel steering. Was left behind with the time acceleration. Yeah, perhaps. And you'll notice that, well, since we're now in reversion mode, the IRSs have lost alignment. They'll still try and give you reversionary attitude, but they are now using only accelerometer and gyro data to try and intuit what our actual attitude is in space. And that is nowhere near as accurate as following, actual proper IRU data or proper initial alignment and then following on laser gyro rotations. So you'll notice right here after the slashes, this is the error in the respective parameters. So we have a 0.4 degree heading error already. Pitch error is about 1 degree. Roll error is about half a degree. And they are pretty much best effort at this point. Alpha R93, thanks for the follow. Welcome aboard. And at this point, the IRSs are basically operating in exactly the same mode as this standby instrument is operating in all the time. In fact, they might be showing very similar information. So all the errors are essentially going to propagate into them. And I gotta figure out why the hell that thing... In magnetic mode, it should work. Whatever. However, we do not get, we should get a map position. The map is not shown. Interesting. We should be getting something. Where am I even? Alright, it probably doesn't know. Theoretically, I'll need to work on this. Probably need to work something out. It should be giving me... How far away am I? Forwarding 2. Let's go SJC. Correct. And map. And of course. I need to check. It should be giving me something here. Now we don't get, you'll notice, there's no more velocity vector, so there's no flight path vector anymore. That is gone. Could still navigate conventionally, I guess. Can we navigate like this? Localizer 1, sure. Let's go ahead and tune in some sort of a radio nearby. San Jose 1141. Echolog tuning. Yeah, I know. I don't care. I'm not going to do an approach. Oop, no, not that button. That button. Could I go and follow you in VOR steering? Yeah, I could. And we crash. Okay. Well, time to debug you. Nav to nav, no approach. What? Control app, nav to nav, no apper. FMC subsystem. Nav to nav. No, not nav to nav. LNAV. EP control LNAV dot C. No. AP control nav to nav 372. Setup failed. Why are you asserting this? Why aren't you? Why are we setting you up? Pre-setup. Port none. Sure. How did you get there? So you got to 431. Nav to nav setup failed. Nav to nav setup failed. Huh? Nav to nav setup failed. Yeah. What the hell cleared that flag out? Alright, because I'm in... Yes, I probably know, because I've switched over to conventional nav here. I'll have a good one. Graham, see you later. Hey, bugs. Okay, so nav to nav. Setup failed. No, nav to nav, no apper. This gets cleared once we're out of approach mode. That this goes away. Okay, but then we are clearing the setup status flag. Now we're also clearing it there. There, okay. What the hell? Where can this get set to nothing? Setup done arming. No apper true. Update now after no apper. Hang on. 431. Update the nav to nav setups. Betcha I forgot to set something here. So where do we set you to false? So you get set up here to false. Port none. Port none. Oh no, hang on. 431 nav to nav setup. So this needs to be cleared out as well when we switch over to conventional nav. FMS on side. No apper pre-setup. Pre-setup. What the hell's this called? Huh? So not there. No apper pre-setup. We get into no apper, maybe it's more like this. Where we not, no, hang on, where we lower the flag. Oh, yeah. Reminds me of MS-DOS edit. Yes. If I look at it long enough, I start seeing magenta square where I look away. Oh. So how could we have gotten this point 431? Failed. Up. 668. Okay, so update nav to nav. First we do the setup, then we do the transfer. Setup goes to 431. Get next nav to nav approach. Nothing here. Approach control, reset nav to nav. Good. Nav to nav setup failed, and then we just hit dirt here. We would expect this flag to be set. Nav to nav, no apper. Nav to nav, no apper. However, if we are Right, yeah, I think I'm starting to sort of grasp this. Nav to nav setup done. Nav to nav setup. We were in the check log tuning. Yeah, check log tuning was the problem. I switched it away. So check log tuning state. Yeah, okay. Check log tuning. Tuning okay. Yeah, setup failed. Setup failed. But we could have, no, that's, I think it's just a superfluous condition here. Because 372, hang on, should we? Nav to nav setup really doesn't have to happen when we're in conventional navigation. When we switch over to phosphine from the blue background. What? Nav source. Okay, so if this is VLOC, let's switch to VLOC. It's just a debug system. Setup none. Ah, so this should probably not be here. It should be like here. If the source is on side or cross side, then we are gonna check, otherwise we don't care. It's not being VLOC on side, nav source act. So if the nav source active is something other, then we go nav to nav apper no. Setup abort none. Actually, no apper pre-setup. We'll just solve it like this. This should cover this use case. So get this thing back on the road. Or just continue the flight. Airplane's going to be a little bit pissed off, but we'll get it sorted. So what was the outcome of ground speed acceleration? How long does this level of coding take to learn? Well, Hawkfish, I've been at it for 20 years now, and you never stop learning. So yeah, it's not a one and done thing. You keep on learning. Oh, come on, piece of shit. X-Plane sometimes does a Vulcan device loss to me when I resize the window while I'm while it's loading up. Just trying to get it to fit into the screen window and stuff. You know, your whole professional life. Okay, audio is going to come on in a sec. So, X-Plane, hit me. Come on. Don't fuck yourself. Okie doke. Oh, wow, it's kind of regained alignment. Well, let's fix that. How are you still in alignment? Oh no, it's not. It's still just the old stuff that I had there. Okay, so swung for one, I think. Check low tuning, yeah, whatever. No low tuning for you, mister. Putting this or TBM orange or TBM or this one here. This definitely is a lot more fun than TBM because I don't have to. In this, I'm not constrained by what some broken piece of crap is gonna do. Why are you now saying localizer? That's still up. Don't tune no localizer, dude. Yeah, check low tuning. No, loc will not be tuned. Why is it trying to do a set after nav setup when I've told it not to do that? When we're in conventional nav, it shouldn't be trying to do it anymore. That's another thing I gotta fix. Gotta lock out that piece of functionality. And then super scratch it if I'm filling into or something else. Yeah, I suppose, yeah. Of sorts. So what is my heading currently? My magnetic heading. 275, and it says 277 on here. Oh, I gotta go and fix that again. And yeah. That's the thing when operating in reversion mode. Your heading is going to drift quite significantly. Roll is misaligned by about 1.5 degrees. Pitch is by 1.5 degrees. So there you go. Now figure out why the hell that heading mode didn't work. It should. So this is going to be under FCC mode. Activation of modes. Activate lateral mode heading. Or heading from user. So that's not the problem. FCC mode. FD control. Update FD target heading. Heading select, RS heading. Huh? So RS heading. What are you? Are you the true heading or are you magnetic? Get heading. Do I have a function for that? No. heading rate. We don't care about. Let's go ahead and debug this. So brake, FCC, FD control, 190. Like that, good stuff. FCC IRS heading, that is present. FCC out airing heading select is present. Heading miscompare we don't have. IRS heading rate. Ah, right, it doesn't have heading rate. Which means there's a little fix I gotta put into the inertial nav system. Heading R. Where do you compute heading R? HDGR. Heading R. That part of the solver here. HDGR. Heading R. Okay, update orientation data. Normalize heading psi. Ah, right. It's deriving it only from the true heading. So, for what are we doing? More crashes. No, I'm trying to work out why the hell this damn thing isn't giving me heading rate data, or why it's not letting me engage heading mode and reversionary attitude, because it should. As long as I provided with any kind of heading reference, it should give me heading mode. So heading magnetic. What I could do, right? HDGT previous. What do we use that for anyway? HDGT previous. Set you up here. Up there. You know what? I'm gonna just keep a second one. So HDGT previous, HDGM previous, and for cases where we do have only magnetic heading data, we're gonna use that. If is valid heading. Otherwise, if is valid heading. Sure. Variation. We even get here. Brake, laser F6 solver 351. No, so we don't even get to this spot. HDGR, therefore, solver reset out data. So in that case, because solver reset out data is being called because we don't have any reversionary mode data. Maybe not. Hang on, is it even... What the hell? How did that even get set? HDGR. Where are you being set? Only here. HDGR. Eh? Oh, it's a laser F6 solver. Heading rate. Heading rate. Heading rate. It's probably just because it's not being populated at all. Update attitude reversion. Heading magnetic valid. Yep. Autonomous output. So we're just... Okay, so if we have a previous... If is valid heading IRU solver, autonomous output, I think that's what it's called, isn't it? IRU solver out data, heading magnetic previous, yes. HDGM previous. Then I'm going to copy this behavior here. But instead of using true heading, we're going to use magnetic heading in this case. Do we have a delta time value? Yes, we do. And this is going to go... Are you solder out data? This equals address of that crap. Heading magnetic, set it up there. Normalize heading psi. Sure. We have a valid heading. Then we're going to derive a new heading. Heading rate, rather. Data heading out rate. Going to be the heading rate. And also we're going to store it. So data HDGM previous is going to be data HDGM. With this in hand, we should. I'm going to have to externalize this one, don't I? Track update rate. Yeah. Go away from here. Go in here. Good stuff. And reload. On your desktop, there's a CL650 beta icon. Would you consider it beta already? Pretty much, pretty close to it. Santeria, thanks. Glad you're having fun with it. So, we now have a proper heading rate label coming from the IRS. Do we? Yes, we do. So with that in hand, we do get heading mode. Heading mode ain't doing nothing. Why aren't you doing anything? Okay. So it's not killing the mode. Update heading steer. Steer heading. So is NAN heading true and is not as NAN, not as NAN. Ah, right. We have IRS heading magnetic in here somewhere. It's the impulse. So here are the inputs to the flight control computer, and it does have a heading magnetic setting. Final used auto selection. Yeah, okay. And is NAN that or not as NAN FCC IRS heading? Any one of them will do. And reload. Time to go IRL calls. Have a good one, Intel FX. See you later. If the file got saved, but the reset function had heading T previous twice. There it goes. So now it's steering. Let's see how well it steers. Bye-bye, flight path vector. At heading T previous twice. It shouldn't, because otherwise it wouldn't have compiled. There's a Ref6 solver. HDGT previous. Oh, right, that one. Yeah, I know what you mean. Let's see if this... I broke it. Thank you, Pilsners, for the reset function. Yeah, reset function. This guy needs to reset it both correctly. Good Good stuff. So, still out of alignment, or not aligned. How are we looking on the heading error? Not much at this time. Pitch is a little bit off. Roll is a little bit off, but who cares? That's the thing about real avionics, is really designed to deal with a lot of sensor input, noise and error, and just crap. So the avionics doesn't sweat that it's a little bit out of alignment. Who cares when a pitch is a little bit off? The autopilot's going to try and steer the nose up or down as much as it needs to keep a certain altitude. That's how these control cascades are designed to essentially function quite well, even without alignment. And this here flight path vector is probably now synthesized. I'm trying to think from what? Probably coming from the GPS system, which is why it's so laggy. Normally it'd be much closer to my actual flight path, but the GPS is fairly delayed when following. The red here is your GPS estimated velocity direction or true track, and since GPS doesn't actually give track, it needs to drive that. Can you realign the IRS in flight? Bottle, in reality, I think there's some way to get it done. I haven't bothered with in-flight alignment because it is very, very complicated in terms of the algorithm, and it's a fairly rare case anyway. I might at some point, I don't know. Yeah, why aren't you giving me a path here? So, what is the problem here? I think there's just too many assumptions here about what sort of sensor data is going to be available. Because we should be seeing, if the IRS is providing a magnetic heading, let me think. No, actually, we won't get a map. Yeah, because the IRS, even though it is giving a heading, it is not, that heading is not referenced to true north. We don't know the magnetic variation, so we cannot give you a spatial orientation for mapping purposes. That is why there is no airplane symbol, even if I bring up the plan mode display. Yeah, there you go. You can see that there is a PPOS icon there that's moving. It knows that we're there. That is our position, but it doesn't know which way we're facing. So it doesn't know which way would, even though we know that, for example, we were facing at 110 magnetic. With respect to true north, it doesn't know which way 110 magnetic would be. Is it that way or that way or that way? But it can't actually draw an airplane symbol, and therefore cannot give you, when you're in this kind of a map display, in this kind of a display, it can't give you a magnetic or map visual. But it will show me where I am, at least that. And I can still navigate conventionally, so I can still fly a magnetic heading just fine. I can still do an ILS approach. I can still do a VOR approach. So the airplane's still perfectly safe to fly. We could still go ahead and fly vectors, for example. Vectors to an ILS. Nothing different than before. Now, our attitude is going to be probably fairly out of whack. You know, up to 5 degrees of error could happen. The IRS is going to try and keep that under control, but it's a fairly tall order for it. In fact, if you go to, let me show you, Laser F6, and there's a performance chart in here at the tail end of the manual for the inertial reference unit. You'll see that there are two columns here in normal mode, in nav mode, and then in reversionary attitude mode. And so pitch and roll angle, 2.5 degrees 2 sigma, 2.5 degrees 2 sigma. Half a degree. Ooh, that's nice. TSOC4. This is much better. Basically, my crappy one is about there. 2.5 degrees, 2 sigma. Whereas in nav mode, 0.1 degrees. It's a lot more accurate when operating in that kind of a mode. But at this point, we're slant alpha nav. And no flight path factor. And also no synthetic vision, at least didn't let me. Yes, SVS inop. Because the synthetic vision computer cannot do that now. So I can still read my position sort of off of there. I remember if I go to center position, there we go. Go delete center position, then it'll follow my airplane. Or will it? Yeah, I'm trying to remember. I know it is. It's following with me. This is now true north. Interesting that I can. No, we should be able to actually give you magnetic variation from here. How was that? That X-plane doing something? Interesting. It's giving me a flight path vector here, but not on the HUD. Yeah, because we do have magnetic variation, because we do have our own magbar database inside of the FMC. Theoretically, we should be able to synthesize some sort of a true heading for you inside of the FMS. Interesting, interesting. Of sorts, we should be able to do that. Now, select approach, dep R. Actually, you know what? Screw that. We're not even going to bother with it. I am going to bother with it just for the purpose of getting charts for the damn thing. And I'm going to go into upper menu. Put it there. And this guy's not going to show where I am because he has no clue of the orientation about me. Cool, 110.9er. Look, will be tuned. Yeah, sure, 110.9. And slow down to 210. Where we run off there too far. Change. Yeah, I could turn on this guy here. Not that you want to fly on this. This would be quite the horrible way to fly an ILS using this little instrument here. But it's there, it's capable of it. Let's turn like there. 306 would be the course. I'll set you. Oh, you're still set to the same course as before. So let's set up like a 30-degree intercept or something. something like that. I'll come down to 2,000 maybe. Well, Souflyer, I'm happy you're coming. I realized there was a heading bug on a 1,000-foot tape thing. Heading bug. Not sure which tape you mean.
2,500.
I probably came in too close. Yeah, I came in way too close. Up to 250 or something. Altitude bugs, stop thinking. Altitude token, that was a tape thing. Oh, that one. Yeah, the mini. Yeah, the mini tape. How are we looking on the quality of the state tracking here? 1.2 degrees roll error. Let's head further out that way. 3.4 degrees magnetic heading error. Yikes. Yeah, that one we gotta pull back. So, once I level off here, I'm gonna adjust the heading. And you got to do every, few minutes on inversionary mode, because there is no magnetometer on the thing. So go to IRS control. I'd read off my magnetic heading off the compass. 130 set. Actually got to up a little bit further up. Probably. There's some terrain here. Not giving me all warm and fuzzy feels. One and a half degrees of misalignment on the roll axis. And let's see if it's going to correct itself if we fly level for a little bit. It should. It looks like we're slightly rolled to the left. I'm pretty sure we're actually essentially flying fully wings level here. Just that slight misalignment looks like it's a horrible error. Slowly pulling it back. .3, 42, 40. When you're flying level, it basically it sees that there's no significant acceleration on the aircraft. So it assumes that, okay, you're probably flying fairly stable. So it's going to look at the accelerometer status and determine, okay, which way is actually up. And then it's going to slowly correct the attitude back to what it thinks the accelerometer data is giving. Now, when there are significant accelerations in the airframe, then it can actually provide bad data. So for those cases, this data actually gets filtered very, very slowly in there. Especially when there's any kind of high dynamic state, this actually will get fairly slowly corrected. Good stuff. We're about 5,000 cool, so slow down to 210. Now can we actually get an ILS capture? And when you're turning, actually, there's a separate algorithm that's being used. Because right now we are turning at fairly high angles, and that would normally result in quite a lot of, it wouldn't be able to use the accelerometers to determine, because it would think that we're like wings level because we're flying coordinated. But in reality, what it's using now is the G meters, or it's assuming a constant bank angle turn, and so it's using the G acceleration of the aircraft to try and determine whether we would be, what sort of bank angle we would be, because there's a correlation between angles and there's a correlation between bank angle and vertical G acceleration. Yeah, this is GPS derived because I can see it's kind of led me, and then it's going to come back. And we're in the approach mode here. Approach look 1. Altitude select capture. Yeah, the pitch error is, they kind of trade places, roll and pitch error. Currently we're less than a degree error on both of them. And when you're in unaccelerated flight, it actually can get fairly accurate. I'm going to deploy some flappage here. Light slow capture. Do I still have my minimums? Yes, I do. Yeah, this is now flying without a flight path vector. Perhaps I should be showing that, because that's where we put your flight director info. So that should show FPV even when only FMS sourced. And there we go, established on an ILS, conventional approach, everything. We don't have a wind indicator because we don't know what the wind is, because we need an alignment for that. But you see, there's our positions. Actually, our position is right there on the edge of that letter P. That is the actual aircraft position. That's how the thing shows position when it doesn't have an alignment. You can see that before, when you fire up the avionics just freshly on an aircraft that's just booted up, you'll see that. And yeah, perfectly normal approach. Okay, landing, lights, bar, dropping, repulse. Oh, I know, I recoded that. Okay, I know. That's going to be a little bit annoying to fix, because I'm going to have to back out another feature. I have to have Goran change the click spot to something else. So 2,500 feet, we can go and decelerate to 160. Throw out some flaps. And thrust reversers, we got ground steering enabled. All of those are looking good. Yeah, still tracking centerline localizer and glide slope, so not a problem. Airplane's still flying perfectly fine, just on conventional navigation. This guy over on low glide slope as well. That piece of cloud there is super annoying. It's just about covered. I can actually see the runway through there. Good stuff. I can do quickly just cause. Or send some V speeds over. Actually, no, we're gonna pull in the current weights and resend those. Good stuff. I'm gonna decelerate to 131. That'll be BRF plus 5. Final stage of flaps. Yeah, we probably do have a little bit of wind here coming from the left because I can see the nose of the airplane is a little bit to the left of the runway. Yeah, this looks about right. You're going to have just about on the horizon with the nose on an approach or even slightly below. I'm actually flying a little bit slowish. Probably a couple knots extra on there. Like 134. I don't know, something like that. That kind of a sound, dude. Yeah, there we go. All right, the Jeep had priority. That was why it kind of sounded like that, a little bit weird. Yeah,
Approaching minimum.
that guy's not helping me at all there. I'll just go off the pappies there.
Minimums.
And continue.
100. 50. 40. 30. 20. 10.
I think this is the same taxi we re-exited last time, isn't it? Probably. It does look fairly familiar. Nope, not the same one. Well, whatever then. No, left Juliet, that's the one. Ah, you were answering Bottle. I know it doesn't have auto land. Almost no business jets, or no business jets that I know of do. Okay, so Loke is Gonzo. That's all good. So get rid of the flight director there. Yeah, so airplane's flyable. So yeah, that was Cat 2 certified, yes. Yep. Or it's just gonna fly you into the runway. In fact, you want to see what it looks, well, not on this runway, perhaps. Try a different runway. Let me just check one thing, and I'll check which runway we can actually try to fake an auto land on. Ah, yes, please. We just do a quick test here, or check through some parts. 30 left, 12 right is, yeah, that one's using the same frequency. RNAV, 12 right, ILS, ASFO. Approach, 10 left. That's an RNAV. Okay, I'm gonna try it at SFO, which is a real fun 7.5 seconds to touchdown. The last 80 feet is up to the pilot. Yes, sir. So get some flaps out. Get this reset. I'm gonna take a quick turn here. We're just gonna jump onto the runway. Do a quick takeoff, no consideration, no lube, and just get it up into the air, and then we're gonna jump over to San Francisco, and we're gonna see if we can make it crash into the runway. Yeah, I needed a runway that didn't have a same frequency localizer on the other end because of a bug here in Liberator, which is gonna be fixed soon, but currently isn't. Where it wouldn't give you a localizer and light slope beam in the last about 200 feet. Cool. That and that. Still Tarang, so TARA. Funny story is even without an alignment, it would still give you resolution advisories and everything. So, perf, do I have a temperature set? Yes, I do. Okay, cool. So let's go. I want these two on. So we're looking for 120, about a good speed for a rotate here. At this sort of rate, just by going by memory, I know it's going to work out. Yeah, cool. There we go. This is the flight director there, gear up.
Flight slow.
Yeah, it's a little pissed off. Good stuff. Do a flight level change. Flaps up. Sync up the heading here. Not that the heading has much meaning with no alignment. It does something, but not much. What was that story about Challengers having problems doing very short flights at the factory? Yeah. It's not the airplane having trouble. The airplane's just fine. 10955. 1955. Course is 284. So about there. Not even that far off. Thank you. Actually, I already got to start slowing down here because we're barreling in. Oh, no, not that one. Right. That's the button I wanted to push. I gotta realign my heading again. 332, right? Yeah, 332. There we go, localizer capture. Now my heading won't actually work. I gotta wait. 17 miles away. Let's start the descent soon here. Now can I have a look at my heading? 281. 281. That heading. Good stuff. The model, the story is that if I had kept the wheels down, they would have been kept on spinning, and that can confuse the auto ground spoiler deployment system, where it's looking for either wheel spin up or weight on wheels. Either one of those will, if thrust levers are closed below, you know, something like, I don't know, 6 or 9 degrees or whatever the number is, if the thrust levers are closed, you know, it meets the ground spoiler criteria, and flight spoilers are pull. There's also the pull. Yeah. Or CL650 pilots should probably also trigger if you pull power to idle. It would also do that. There we go. Glide slow capture. Slow down to 180. We'll get some flaps out. I think San Francisco, their typical operating procedure would be 180 to 6 or 160 to 4. I keep forgetting which one. I think 160 to 4. Whatever, but who cares? You'll see that that's the extended runway center line. That's because I've inhibited sequencing on the final approach there. If it's 160 to 4, I don't think this reads 0 at the runway, does it? The classic American notes reads 1.9 at the runway. So 4 would be 5.9. That would be 4 miles from the threshold. 180 to the bridge. Well, I think that's the bridge. Just barely. We said we want to see what happens if we keep on driving down to the ground. Let's see. Now, depending on the speed, you might not get too bad of a crash. So for some funsies, I'm just going to set it up early. Something like that. 136 knots, sure. Flaps 45. Oh, let's wait. I'm going to pretend I've got auto land, even though I don't. I do happen to know what will happen, which is not much. Now, if we had a bit of crosswind, that would have been a different story. How are we looking? Oh, not too much crosswind. Even got the 3-degree descent path. That's from San Jose over there.
1,000.
Correct. How far are we looking? Wait, we got nose a little bit below the horizon, not too far. Now, if we were flying significantly faster than VREF, then yes, we would have nose quite low, and we could actually break the nose gear. But I do think what actually is going to happen at 100 or at about 50 feet, it's going to start reducing the power. If I just left it in auto throttle, it's going to start reducing the power, and then the speed's going to bleed back. The autopilot might start pulling back on the nose to try and maintain a glide slope, even though at 50 feet, there's not going to be much of a glide slope because the glide slope transmitter is going to be like 45 degrees away from us, so that's going to be barely any glide slope left there. And if we lose glide slope, it's just going to revert to holding the same pitch. So let's see.
approaching minimums. Minimums.
There we go. See you bounce.
50, 40, 30, 20, 10.
Is the autopilot trying to keep the nose up or something? I think it's full back stick, isn't it? Yeah, essentially fully back on the stick here. Is it pulling the tail on the pavement yet? It's also fully nose up trim. Also pulling in full left on the ailerons. Interesting stuff. Here's our inputs. There's our auto land. And almost auto land. AP holding nose up. Yes, I know. I noticed. Aero braking. This is too hilarious to not see from the outside. We're gonna turn down the noise here a little bit. Almost dragged the ends. Survivable. Yeah, barely. What would you bet your aircraft on that? Yeah. What do you say, CL650 pilots? I think I've seen worse ones in real life driven by pilots. Yeah, you can see how it's slowly moving the stabilizer, fully nose up. It's fully up on the elevators. And now as it's away from center line, it doesn't understand anything about ground steering where it needs to use the rudder to steer. So it's just trying more and more aileron to try and steer back because it doesn't understand it on the ground. Ailerons don't do anything. So yeah, hilarious. Hilarious. Cool. So, I think that's going to do us for tonight. Much fun has been had. And, just be dreaming, you and Brett's in one day. Richard Train, I'm sorry, I'm just about to finish the stream here. So you can go ahead and watch the VOD, I guess. As it's getting on for almost 11 o'clock here, so I gotta wrap it up. So thanks everybody for stopping by. And yeah, I guess I'll talk to you next time. See you on Discord and all that good stuff. Everybody take care. Have a good one, and love y'all. Bye-bye.